How do you see if the Podman image is, or machine is up?
Maybe Podman machine info. Or if you try and Podman machines started, it might say that it's already.
Looks like it's got right. Yeah. I think I need this desk to be like exactly this tall to be comfortable on my wrists, right?
Isn't it the standing desk that you can raise?
Do you think so?
I think I've seen someone do it before.
Is that person smarter than me, though? Because it doesn't help if someone can do it, right? Oh, wait, what's this? Huh. Well, all Ari had to do was walk up here.
He's not powerful.
The threat.
I was like, I'll do anything. Let's make sure sound's working. Sound's
Most
working.
people in machines can be motivated by threats.
Yeah.
First is to be taught. Exactly.
How's everyone doing? Cool. This is the week off C. So I think I've been doing things in a 2-week cadence, right? So conventionally that would mean that you were supposed to get 2 weeks off of C with spring break. So what I did is I picked up a bunch of sort of modern development software, not really software engineering, this is sort of the opposite of software engineering. This is what people do instead of the waterfall agile thing, right? So CI/CD. I'm going to try and teach some of that stuff, and I'm going to do it in the context of the C programming language, but it's language agnostic, right? So this is a lecture in 2 parts. The first part is just about one additional Podman technology, and then the other one is the CI workflows on GitHub, which some of you may be aware of, and we integrate that with the make system. And so the combination of Podman mounts, GitHub actions / workflows, which are like related but not exactly the same thing. It's almost just like 2 words to describe different parts of the same structure. And then make, which I'm not going to sort of teach make classically because it's like a large topic, but I'm going to introduce make. And so at the end of this, sort of 3 things that should be separately interesting will be introduced to you, and I'm not going to teach any of them in depth. But in fact, each one of them could probably be, at least CI/CD could be a whole class, that's no problem. I don't know that you would teach a class on make, but you might teach a class on like build servers or something like that, right? Yeah, make, M-A-K-E. See, that's Windows. So does Windows have make on it? No. Then we come over here. Make is a command. Right, okay, so do you have to make one announcement? I traditionally try and avoid giving assignments that are impossible. And after careful thought and consideration and doing my best, I am relatively confident that if you implemented everything in this class the way I expected you to, which does not mean the only way or the required way, that your prime number generation would take very, very close to infinity time. The reason for this is not too surprising, and it's actually based on the reason that RSA is not used anymore. So anyways, I have provided an example of big prime generation using libgmp, which is quite fast. It's not competitive, but we should talk through this a little bit so you know what's going on under the hood. When I wrote a primality test for 496-bit integers, the most natural way to do this is to use witness checking, where you take a number and first you make sure the number is odd, right? Or you do 6k plus 1. And then you start dividing it by larger and larger numbers. Now in my case, and let's think through this, when I take a division in big div, I need to keep track of a numerator and a denominator and a quotient and a remainder. That is 16,000 bits. That's a lot of bits, and those bits aren't free. And the more bits I use, the less likely I am going to get my fastest bits in my device. Most likely, in my physical computing device, I have something called an L1 cache, which is the fastest bits I have in my computer that are outside of the actual CPU. They're very close to it, right? I'm guessing I have 4,000 such bits, right? And so that means I can fit one of my 496-bit integers in there. And you're thinking, well, you can't do anything about that. Oh, but yes, I can, because the overwhelming majority of the numbers that are not prime are going to be found to have a factor much, much smaller than 496 bits in size. And I am only going to look at prime numbers that are around 2048 bits in size, right? So I should be able to fit all of this in my fastest memory. What I'm probably having to do is go to the next biggest memory, which is probably 4,000 bits, and is probably a tenth the speed. So I'm assuming I'm getting twice as much space and 10 times lower speed. And you're thinking, well, that's not too bad. 40,000 bits, that's probably fine. No, my big div is implemented recursively, which means it's maintaining a call stack. So for every 64 bits of division I do, I'm essentially creating a new big division function. And that big division function is maintaining its own remainder and its own quotient, which means I'm adding 8,000 bits every time I recurse. I'm recursing every 32 or 64 bits, depending on which flags I have set in my compiler, which means that in a 2048 size integer, I am recursing 64 times, adding 64 times 8,000 bits. And 64 times 8,000 is more than 40,000, which means I'm going to the next biggest cache size, the L3 cache, which probably has 4 kilobytes. Is that right? No. 4 megabytes, which is in fact big enough and is in fact another 10 times slower. Now I'm running 100x slower than you would expect. I'm running 100x slower in an exponential function that contains multiplications inside of it as well. So doing everything 100 times slower is in fact going to generate the appearance that my code is standing still compared to libgmp, which is doing the same logical operations, but is never maintaining all of the extra bits except in the very special case where it has to, which it has a likely prime of a very large size, and it's only going to compute the cost. It's only going to pay the high cost of doing the big multiplications for the very small subset of divisions which it must do this, right? Separately, this avoids me having to write my own square root function. We made fun of Ari 1 or 2 weeks ago for asking how to write square root. You actually do have to write square root as soon as you stop using the built-ins, right? So I was going to write a binary search square root, and in fact I did, and it worked fine, right? And it was unbelievably slow. So I hadn't actually written a manual prime generator for a few years. I was sort of just assuming modern computers were so fast that running several 100,000 times slower than you'd expect wasn't a big deal. Turns out it is, and several 100,000 times slower than something that takes a couple minutes is a couple days. That's just how it works out. This is the thing that is several 100,000 times faster. I'm going to just talk through this quickly so you know what we're looking at, and then this enables you to use the same tech stack on the rest of things. I would still encourage you to write a primality generator. I found it a rewarding experience, even though when I turned on my code, it instantly came to a standstill. One of the benefits of writing the code, even though it doesn't work, is you can use it over a 32-bit integer and see that it does work. And then separately, you can think about how much work it would be to get that to run faster, which is a good thing to be thinking about, right? So what do I do here? There's one critical learning objective to introduce here, and this is dev random. Dev random is Can I do this? That does not look random. So we're going to say this is pseudo-random, which I think is probably fine. And this is a simulated file. It is not a real file. It is an imaginary file that exists on many but not all Linux systems. Dev random is meant to solve the problem that no one really trusts anyone else to implement random number generation, so this got farmed out pretty quickly to the hardware engineers, who sometimes do have access to like a little quantum unit that can at least truly randomly seed random number generation, right? One of the things you can do, so you can take head random, and you can pipe that into an SH8256 sum and get something that looks this is quite likely to be random, right? And that will give me a different result every time, right? And so this is a good way to get things that are pretty random, right? I've been advised that for real highly invested safety critical stuff, you still shouldn't use this, but for the sakes of security research and academic practice, this is the preferred way to generate random numbers, and it is not, in fact, the random library in C. The random library in C is C functions written in C. Dev random, in theory, could be hooked up to a hardware device that generates something that is more plausibly random. So, if we don't have a way to write it in C, we have to have some other way to get access to it. We have to have some way to access that piece of hardware, and the preferred way to access that piece of hardware is through this simulated file. There are other such simulated files, of course. The one I use most commonly is dev random, dev null, which causes things to disappear. That is a simulated nowhere. That is how we send things to the shadow realm, never to be seen again, so we can banish them from our perception and our knowledge. The other aspects of this provided code are, in my view, relatively uninteresting, but the presence of init and clear is going to be a lot more interesting after break when we start dealing with memory allocation, which is an interesting topic, and it is the technology that is required, in my view, to implement FAST496T the correct way. And so rather than ask you to do that now, we will show this instead. Now, RSA has fallen out of favor. It has been replaced by ECDSA, which is an elliptic curve thing. Why is that? Well, it is for this exact reason, actually. RSA, from observing the memory usage of a device generating keys, you can infer large amounts of information about the keys. This is through some complicated mathematical operations that are basically beyond my abilities to understand, but I think we can all understand that if you turn on key generation and it takes longer one time than it does another time, the thing that is quite likely to be taking longer is it's taking longer to find one of your two primes. What this means is that it is likely that your keys contain a prime that has not very many preceding primes. And it is also likely the case that most of the primes of around 1024 bits are known. So all you have to do is pick a 1024-bit prime that has the expected distance from its previous prime, and at high probability that will be the prime that seeded the algorithm, right? Now, the reason you can even measure that is because divisions are so slow and expensive, they are observable, right? So you can tell how fast this is running. If we could divide things in nanoseconds, we could do many such divisions in nanoseconds and there would not be a perceptible difference. Perhaps there would be a change in the amount of energy used or something like this, right? But because this is an expensive operation and it takes an unpredictable amount of time varying from several seconds. I think when I ran this, and maybe we should just run it, which is probably non-trivial to get to work. Let's see. So we'll do Vim. In order to run this, I need to define bytes. Well, I'm going to need standard I. Am I going to need standard I/O? Yes, I'm using file system. I'm going to need libgmp. I'm going to need bytes is supposed to be 64, right? And this is supposed to be...
Would it be 64 times 8?
Probably. This one's 64. What is 64 times 8?
40 times 6 divided by 64. No.
It's about 12, right? Yeah. Okay. That looks correct to me. Are there any other... Oh, I need standard int. And then we can... I can do void main. That's allowed. I need a big thing. Big 64. And then I'm going to prig big... How many words do I want? 32 words. I'll generate a 2048-bit prime, which is 32 times 64. My words are 64 bits in size. And I think I think that's plenty. Ah! What, help. Okay. There we go. Cat. Okay. Fatal error.
It's just GMP.
Oh, it's just GMP?
Yeah.
Why is my device chirping? Can I mute it? Let's see. Oh, I'm using memset, so we will include string. Okay. That is a very high variance in performance, right? 6 times slower the second time. That tells me a ton of information about which prime I found. Now, I don't know a lot about prime generation, right? But that is unbelievable, right? And I don't know what's going to happen the next time we do it. Right in the middle, like what is going on here, right? So these things are, the primes generated are random, and if you know how long it takes to generate them, they're not even close to random, right? This is going to dramatically restrict which prime you could possibly have. And the more times this happens, the more a potential attacker is perhaps somehow enticing you to continually generate new keys, right? The more times it is observed how long that takes, you get more and more of an understanding of what the predicted distribution of primes are, right? So this is leaking information like crazy. Like, look how much faster that is, right? So this is at high probability a prime that is very close to other primes, right? And at high probability, that one is 10 times further from the next preceding prime. Now, you have to make some assumptions like the fact that I'm increasing which number I'm checking every time, right, instead of decreasing, but that doesn't really tell you that much either, right? The only way to really game this is to reguess a random number every time, and then you're paying the very high random number generation cost, which is also quite expensive, right? So, this being expensive is what causes RSA to now be insecure, and is insecure to something very specific called a timing side channel attack. There's nothing insecure about the algorithm itself, but the algorithm does not always run in the same amount of time. It does not always have the same memory usage, which means it is leaking information like crazy, not from within the algorithm, but from these side channels, things that are not essential to the code. If you ever have a loop that runs an unpredictable number of times, it is highly likely that that unpredictable number is correlated with the output of the algorithm. And people much smarter than me, and I think actually much smarter than everyone else, found out a way to correlate this. And so now RSA is insecure. That's why we ask for extremely large keys. And that is why in practice you are supposed to use whatever ECDSA is, which I will learn this summer and then teach in a future year. I think the elliptic curves are interesting because I think they're non-integer, which means I don't like them very much, right? But I think fundamentally with RSA, it is the case that everyone tried very hard to use integers for a long time, and I think integers have sort of are no longer viable. So we're going to have to use things that aren't integers now, and I'm very sad about that, right? And in fact, RSA is still secure, right? It is just no longer recommended, and it was the only game in town for a very long time. So to me, as an integer enthusiast, this is a big loss, and so I'll still made you use RSA this term. But I do think it is, in a way, a good outcome that we got a negative result related to trying to use RSA that is related to why RSA can no longer be used. Are any of you progressing or stuck or have any questions, comments, or concerns about big RSA at this time? Check it out, do your best. If you do SHA&C and RSA&C, that is sufficient. It is, you can always just do this, and then we can proceed with the rest of the class, right? So, there we have it. I think that's all I needed to say about big RSA. Okay, maths. We are post-midterm. Oh, I talked about the midterm last time, right? I think I did either base 85 or base 64 in front of all of you, right? Cool. So today we're, and actually quite a bit this week, we're going to talk about everyone's favorite operating system, which, as we all know, is Microsoft Windows. Yes?
Sorry, before we get into that,
Mm-hmm.
do you mind going over again what our final assignment expectations would be? Just because I know all that, I copied them, and those are pretty great to start thinking about that. Like, is that possible? But
Oh, yeah, I don't know. So, like, the goal is that And I'm concerned about the feasibility of this, which is why I have not released the assignment yet, right? What I would like you to be able to do is implement the same functionality as Bitcoin Core. And Bitcoin Core uses SHA and RSA as sort of the core algorithms. And then it separately has a data structure, and I was going to teach data structures this week. That is recursive, which I was going to teach how to do recursive data structures in C this week. And then contains something called a Merkle tree, which I was going to introduce with non-trivial recursive data structures in the next 2 weeks. For the graduate student population, one of the things I was hoping would be feasible, and I think we should talk about this and if this is reasonable, is that you make some form of extension to Bitcoin Core, which would most likely be deviating from proof of work. And proof of work is slated to be taught this day. This is Cynthia DeWork's piece on proof of work, which is, I think, the basis of the Ethereum alternative. My hope is that where this says BTC in C, that is Bitcoin Core in C, or just, I think BTC just stands for Bitcoin. If I type that into Google, what do I get?
The price of Bitcoin.
The price of Bitcoin, right. And the original one is written in C++, which I don't love, right? So the thought is, this will be the code base. The graduate population should additionally write a document describing an extension that is made and why in the context of these two theoretical texts. I don't know if that seems reasonable or not, but I was going to write that up as an assignment description. And in terms of thinking about when and how you can do that, I don't feel like I have taught you how to do that yet. The other direction besides an extension to Bitcoin Core is after class today, this will make more sense, but another thing you can do is say, oh, we just implement something that is a lot like Bitcoin Core or has the functionality of Bitcoin Core, but is placed under CI/CD, and you do a sort of like DevOps backend to your code base. And that would also have documentation, but it wouldn't have documentation in the sense of like a conference paper. It would be like, oh, here's like a Sphinx docs deployed from the same GitHub repository or something. And I would like to preserve that as an option as well. My impression, and I did not know this until I gave the lecture in Salem today, is that we did get through enough of continuous integration today that that is a viable thing to ask you all to do. So I think I will probably try and write something up with those two options. Does that seem reasonable?
Yes.
I
I just know that I haven't gotten big RSA working, and so I just want to make sure that I'm still able to try at least. And like, I don't know how the final project and project work kind of goes around reading policy, but I just want to make sure I can set myself up for success with kind of knowing that I haven't been able to implement everything successfully thus far.
Yes, so the scaffolding supports that are meant to support student success on this there do exist for most components of this tool chain. Command line utilities are existing code bases that implement them, right? So it is not unreasonable that when you take an SHA 256 checksum in the context of implementing Bitcoin Core, that you can either use your SHA and C source code, you can use someone else's SHA source code. So there was one that I linked in the assignment that was pretty good, and I think it didn't do NVNS correctly, but you can just fix that. Or you can just use a system call. And the same thing is true of RSA, right? Separately, I don't know exactly what the roadblocks on big RSA are going to be, but I expect them to be related to 4096T. And I do have the, I think call it like the big GMP, which is a interface from the GMP library to the 496T library. So you can write the same code, assuming you finished 4096T or not, and it will either pass through to GMP or not. And so my hope is that this means that no matter what disaster may or may not take place with big RSA, there is some way to get something that looks an awful lot like RSA working. And separately, if none of that works, you can do SSH keygen, though you'll have to extract keys from it, which is not too hard and was intended to be the subject of one of these lectures. So I will work on that over break as well. Going into that, these 4 weeks, the Bitcoin Core functionality seems pretty underdocumented to me, and the current Bitcoin Core library is like 30,000 lines of code. So we're not going to hit it exactly. I'm going to have to write some scripted interface for it. which means that there's going to be a lot of freedom for you to change that scripted interface or for you to talk to me about how you adhere to that scripted interface. So we can sort of expand or contract the requirements. I think the two requirements that I want to see, the takeaway learning objectives, are going to be a recursive data structure and then some form of non-recursive graph data structure, right? And I think those are like fairly expansive and give you a lot of options. What I would like your takeaway from this to be at the end of the class is some repository that has evidence of development in a long-term stable language, and that has some of sort of the CI/CD fluff around it, right? And I think any combination of things that arrive in that and have good documentation to me would make me feel like you learned a lot in this course. And I hope that you are set up for success to do that at some level. Okay, thank you. My hope is that on 8 days from today, I will have all of these links populated. And that often, usually I want to like think about them for a week before I give a lecture on them, right? So like the lecture I'm giving today, I wrote like 3 weeks ago. And so I did not do all of this. I was gonna wait until we got through at least the midterm season. But I hope I will have better answers when we meet 2 Thursdays from today about expectations. Okay. Cool. Any other questions? Yeah, thank you, Haley. Okay. Today isn't really related to any of that stuff. Well, I mean, it's related to the software development side, right? And it is related to the software development side in the following way. I am a true believer in the dev container. I do believe the dev container is the future. I do believe there are competing technologies. FreeBSD has something called jails that I guess have been around forever and are dramatically more stable, and still no one uses FreeBSD because it's too stable and doesn't get recent software developments. There is a competing standard, WASM, which is the WebAssembly people, and WebAssembly seems like it could potentially challenge the primacy of containers in the development sector. I think it is unlikely for that to happen because I think it is underappreciated the degree to which containers solve the encapsulation problem, which is one of the persistent problems across computer science. It was solved with object-oriented paradigm, depending on who you ask, for many years, and it has also been solved with functions, which in my view is the correct way to handle encapsulation.
As far as I can tell, WebAssembly is mostly used for like having it SQLite the web browser, and that's pretty much it. That and a figure user interface.
I do think WebAssembly, I guess what I'll say is, WebAssembly in my mind is like a toy that no one uses right now. But containers were also a toy that no one used for a while until someone was like, wait, this solves every single software versioning problem simultaneously. Then you say, wait a minute, doesn't WebAssembly also solve that problem? In my view, yes. And in my view, containers have one remaining problem, which is actually kind of a big deal, which is the current container infrastructure, the OCI container interface that Docker and Podman and competitors use, requires a Linux kernel to be running somewhere. And I mean, the Linux kernel is like pretty good, right? I don't think anyone has huge problems with the Linux kernel, but it is weird to only be able to use Linux anything. And that is not true of WASM. WASM does not interface with an operating system, right? And operating systems are heavy, and they use a lot of memory, and they take a long time to turn on, and they cost money to keep updated. And if you're in like the defense industry or something, you're worried that an open source operating system you can't trust, and an American-made operating system, you can't maintain the supply line that generates it, right? So operating systems are something that should make everyone nervous, and to me, they're the fundamental vulnerability with containers, right? Now, WebAssembly runs in something called a web browser, which actually is probably something that would have been called an operating system 20 years ago if we showed people 20 years ago what a web browser can do right now, because it can execute arbitrary code, render graphics, maintain state, right? So there's a file system inside of the web browser that does things like manage images. That's kind of sketchy, right? Sketchy in the sense that, like, I don't think when I talk to a normal human that doesn't think about file security all day, they don't perceive their web browser as containing its own file system, right? So it is like no one was informed that their web browser was doing all of this stuff, right? But when you put all this together, and especially think about 10 years ago, like when Google launched the native client inside Chrome, it's like, well, that's actually trying to solve all of the same problems containers did, which is arbitrary code in a very lightweight sandbox, right? I think if you threw the amount of money that's been thrown at containers at WASM, you get the exact same thing as containers. I don't know if I think that's going to happen, but the one thing that can cause that to happen, and I did not expect this, is for some reason Docker has decided to make everyone in the world mad at the same time. And if they make enough of the right people mad, by which I mean either Amazon, Microsoft, or Google, then Docker instantly dies and WASM becomes the new standard, right? And so that could happen tomorrow, right? I don't think it's going to happen. And the Red Hat people are quite powerful and quite effective, and they're going to hold this up with Podman as long as they can, right? But I did, until a few weeks before this class, I was going to teach Docker instead of Podman, and I got kind of nervous about that because it looked like Docker was starting fights it was going to lose. So we'll see what happens. Okay, speaking of file systems, today we're going to learn a little bit about the file system. And we're going to learn about a thing you can do with the file system. I'm not going to implement a file system. A file system is just a hierarchy. You understand the file system, right? We can do interesting things with file systems. I find operating systems interesting, and so we are going to run Linux code on Windows and Windows code on Linux. I did something this week that I didn't know you could do, which is I successfully compiled a C program at the command line on Windows using GCC, which I was pretty sure that was impossible, and I just got it to work, so that was kind of cool. I'm not going to show that at all, it just happened, thought I'd tell you. We're going to do a little bit of symbolic linkages and mounts, and I'm going to solve for me what the biggest problem with containers are, and also introduce the biggest problem with containers, which is that containers are really good at making sure your files inside of the container can't get out, which is bad because your files don't change if you edit them on your host machine, and it is good because it means you can't ruin something on your host machine from inside the container. And I'm going to flip both of those. I'm going to make containers easier to use and more dangerous. We're going to do that using mounts. So here's the motivation. Some of you, and I make much more fun of the undergraduates for this, some of you actually have jobs, and so you get emails like this. And so if your existence is anything like mine, you have someone called a project manager that lives in your life and occasionally asks you if you've checked Teams in the last 7 days. And the answer is yes, because I checked it before responding to this email, but after I got the email, right? So Microsoft Teams has been living rent-free in my mind for years. When I was in grad school, I was the only person in my research group that maintained a Windows device, which meant I had to be the one that made the call to Intel once a week, because no one else's computer reliably could hold the connection, because a bunch of people with CS doctorates were unwilling to get Wine to work well enough to run Windows Teams on it. Windows Teams is like this thing that is holding me in the Windows realm. And came to Willamette, and I wanted to do some additional consulting work for my professional development so that I could actually teach you all what's happening in industry right now, which that's what this week is, right? And all of a sudden, everyone I was talking to about consulting work is like, hey, can you jump on a Teams call? And I was like, yes. Let me reboot to my other drive partition, right? And so now I run Windows full time. And so this is the problem I'm trying to solve. So initially, I was like, no problem. I will have a hard disk partition, or I'll have an old computer or something that has Microsoft Teams on it, right? And then I started being on these calls, and they would say something like, hey, do you think we can get this Redis server to interface with this Kafka stream? And I was like, oh, I have an environment I would check that in on my Linux device, because I don't do development on Windows because I don't hate myself, right? And I was like, well, I can probably do some development on Windows, right? And this is when I discovered WSL and got really into WSL, right? But there are, in fact, other ways to solve this problem, and there's things that I don't like solving with WSL, right? WSL has a separate file system, and it has separate packages, and sometimes that's good and sometimes that's bad. I also like to talk a little bit about LLMs and ChatGPT. I just administered an undergraduate midterm exam, and every single student that used generative AI lost points, even though the generative AI gave them a correct solution, because they were so lazy they managed to screw it up somehow while turning it in, which did not really persuade me that they should be using generative AI, right? So like, one student just capitalized the B in base 85, causing the autograder to not run. That means you can't use generative AI, right? Like that you lost your generative AI privileges. You have to know to not capitalize script names randomly, right? And separately, it means, of course, that every single student that used generative AI did not test their code, which I thought was alarming, right? So anyways, I finally have the existence proof that there is a population of students you can give the answer key to and they will still not succeed. So that was fun. Anyways, I thought I would show them all an example of what happens when you talk to LLMs, which is you can get them to say anything you want. In this case, I got them to say it is illegal to run Microsoft Teams on Linux, which I don't actually know if that's true or not. I'm assuming it doesn't violate anything. This was fun, so I asked this. Actually, I did specifically talk to ChatGPT. I thought I would get a better answer from Gemini because it was about Microsoft products. Gemini clammed up and then crashed. I actually got locked out of Google servers for asking this. ChatGPT I asked twice, and the first time it deleted itself, and the second time it wrote something with a bunch of emojis in it, which is, I don't know what happened here. So one of its personalities turned off in this line, right? Anyways, none of this dramatically increased my confidence in generative AI, right? But like, clearly it's doing something that violates its own terms of service, right? Because it says it can't reply to this based on its terms of service, and then if you just ask again, it replies. I don't know. That sketches me out a little bit. Okay, so in the olden days, I always lived on my Linux partition whenever I was doing anything non-trivial. And then I would realize 2 minutes before my call with Intel that I had to boot down my device and get Windows back up and running. And I turned on Windows once a week, which meant it always tried to install an update, which means that I was always late for the meeting. Separately, I get a lot of things, and I don't know if you all get this, especially when I'm on the job search. I get sent a lot of Word documents that I'm supposed to fill out, and like digitally sign or something. Okay, maybe this only happens to me. But one of the things I've noticed over the years is I maintain a LibreOffice tech stack, which is the open source alternative to MS Office, right? And every single time I use that for something that's supposed to look professional, it puts in like a bunch of like gray background space boxes, or like all of the periods are like a different font size or something. Like there's just like, the LibreOffice people don't really care about Microsoft Windows, right? So they're not trying super hard to be compatible, right? They're just making XML documents. And in fact, they look pretty good, right? But they don't look good enough to show to your boss when you're asking for a raise, right? So, okay, I can run LibreOffice on Windows or Linux. But every once in a while, I just want to sign a document and not look like I'm someone that has strong opinions about operating systems, which no one wants to hire that person, right? So I separately now maintain a Microsoft Office suite on my Windows partition, right? And it takes up gigabytes of space, right? Which means now my boot times are correspondingly slower. It's like, oh, I've got all of this like stuff I have to keep around to seem normal, right? Got them fooled, haha. Right, so then, and this is a very specific example, this MD5 sum. I see these MD5 sums all the time, right? So I was teaching Data 505, class many of you are in Salem on Monday night, and I don't even remember which R library I had to download. But I downloaded it on my Windows partition because I'm trying to seem normal to all the data scientists, right? And it spat out like 6 MD5 sums back to me. Now, MD5 sums are much cheaper to calculate than SHA-256 sums and have been known to be insecure since 2007. They're still used all over the place because they have a much lower computational cost. I don't even know if Windows can do MD5 sums. Actually, maybe it can. Can this one? Okay, so it doesn't look like you can calculate an MD5 sum on Windows. Can I on Linux? MD5 sum? Okay, so can we MD5 sum something? Let's MD5 sum. So From time to time in your life, you'll want to use an MD5 sum, not for a security critical application, but you're making sure that some data corruption didn't occur, usually when transmitting large files over long distances, right? In my cloud computing class last term, when we uploaded a bunch of text data into the Google distributed file system to do some natural language processing tasks over it, the way Google required that data to be uploaded is I had to provide an MD5 checksum so it knew there was no data corruption when it was coming in, because they really wanted to make sure I wasn't transferring in something that contained a malicious payload, right? I was also teaching that class in Windows because I was teaching it to the data scientists, right? So these MD5 sums show up for people that use computers even if they use Windows. And just in this example here, right, you cannot compute an MD5 sum naively on Windows, right? And remember, I'm on a call with my product manager when I'm being asked to compute an MD5 sum. I need to just type it in, it works. But I can do it over here in WSL. And WSL didn't always exist. So I consistently have tasks I would perform in Linux that I need to perform while I'm using the Office productivity software that only runs in the intended manner on Windows. That's the problem I'm trying to solve. We can look at another example. Oh, I was going to install Vim on Windows. I forgot about that. Okay. So let's take a look at this separate problem. And I have, we'll make something that's a little easier than from GMP. So I'm going to vim mywork.c. We're just going to make a little hello world here. I saw a student had a file saved on their local file system called boilerplate. This is just this file I type every time. I type this file in front of you every time because I don't want you to forget how to do it. You can solve problems however you like, right? There's a lot of ways to solve different programming problems. I also dogmatically use an integer return type, even though I'm under no obligation to do that. Oh, I'm supposed to invert my screen color, right?
Yeah.
Right. That's Discord. Okay. Where is it?
Scroll down. It's in that screen. It's underneath brightness and color.
It's underneath brightness and color. Oh, right now? Okay.
Terminal also allows you to change your appearance.
Right, how it looks. Yeah.
Wait, okay, sorry. Two people both spoke to me at the same time and I have one brain. Help. Okay. Wait, how do I just turn off syntax highlighting? That's the easiest thing.
And then it's just command syntax on.
While we're here though,
What?
Space off.
Oh, sorry, yeah. Let me turn off syntax and then let me listen to you later. Okay, sorry.
if you like click the arrow, the down arrow, and you go to settings, and you go to the one that you want to change, oh, you need to open the hamburger.
Hamburger?
Yeah. So, yeah, you could do the global appearance or color schemes, yeah.
Oh, I thought this one didn't for
Yeah.
some reason.
I think you have to hit save.
Save.
But I think we tried this last time and it didn't actually.
Right, that changes the window frame.
Yeah.
Right, and then.
It was the
Color
big-
schemes, yeah. So Solaris Light might be good for us.
Any of the light modes would work. It's just that the purple has really poor contrast in the dark background. You might have to open a new.
I think this is just going to only apply to
Or you
Windows
have to set as
PowerShell.
default.
Oh, set as default? I don't know.
Did
Yeah.
you click save?
I have no idea what I'm clicking,
There we go.
Okay. Do you like that?
Yeah.
Oh, and let's try syntax on again.
Mhm.
I'm trouble.
Is that okay? Does that look fine?
I can see it.
Do you like it better with syntax on or off?
I think this is probably the best as far as readability and usability.
Okay. We're going to use this one. Many things are horrifying.
I understand why it's.
Can I'd put like an orange filter on it if I could. Or wait, someone said solarized light.
Yeah, I would use Solaris. If you go back, yeah.
Wait, what is...
What?
Oh, color schemes, I see. Oh, yeah, this will maybe be slightly less offensive.
It's less, yeah, unsafe.
that kind of looks low-key sort of nice to me. That's like parchment, right? Like I'm digging it. Like I feel like I'm in a sepia filter. Like I'm in a flashback.
You can mark your code with like a wax seal.
Yeah, that's cool. Okay. Did I save this as anything? Okay, there's my work.c. Okay. Okay. I hope no one's messaging me about something important. So I have one of those notifications is from Professor Cordova, right? I said some vicious slanders about the .NET framework in class today, and then those popped up, and I'm wondering if I had a snitch, right? I haven't read them yet. That notification's been there for like 2.5 hours. Like I don't know what that thing says. I'm gonna check it over dinner and I'll report back to you, right? But I was like, ooh, is Professor Cordova watching my live stream and heard me like, because in the after dinner part of this lecture, I have the series of 5 slides on why no one should use .NET, right? And that stays between us, right? Outside of this classroom, I love .NET. My favorite programming language is C# and also Angular, which is a language and a framework. Yeah, okay, so all right, here we go. All right, let's vim mywork.c. Let's cat mywork.c. Okay. Let's make a little container file. I think we'll probably just do, am I not in insert mode? There we go. We'll do from Ubuntu, we'll copy mywork.c, maybe we'll like apt update and apt install GCC, something like this. I don't know, something of this nature. We can probably save that. We can probably podman build T. I'm going to call it my work. I do this every time. See that T?
Needs to be a D.
Needs to be a D. But the neuron in my brain that tells the difference between Ds and Ts only works when I'm on a Windows partition, right? So, we're getting there. Copy requires at least one argument.
Dot and the destination.
My work is never done. As David Guetta once said, a hustler's work is never through. That's an exact quote. I made a big mistake. Do you know what the big mistake was?
Using it to do. And just not putting the -y in the command.
Okay, fine, we'll use Alpine. APK add GCC libcdev, I think that's everything. No shot is it actually that fast. That's crazy.
I applied for Java Canonical, and if I get it, my entire work will be making Ubuntu worse and slower.
Okay, GCC slowed it down. Okay. Okay. Oh, look. It's a random number generator. Okay. Podman run. What am I running? Let's see. Over here it says tester python 3 tester.py. That's a pretty bad example. We'll run GCC podman run. Let's just get in there. Okay, there we go. And so we have mywork.c. We can GCC mywork.c. We can a.out. It says hi, right? So we've been through this workflow a gazillion times. That's not what I tried to do. Okay. So I can also, and here's something I would like to do, when I'm developing my C code, I often want to make changes to it. And so perhaps I come over here and I vim mywork.c, and I change that hi to hi, for example. I cat my work and I see the changes are there. I'm like, great. I updated my C file. I'm so excited to rebuild my code and run it again. Come back over here to my build environment, my little build server that I love so much. And I run my code, right? And I'm like, oh, it's still, I forgot to recompile it, right? And so I'm a silly goose, honking merrily about my business, as I say. And I geck my work, right? I'm like, now I'm going to see that GH, right? The GH, of course, stands for GitHub. This is Hi GitHub, is what that's short for. I'm going to go ahead and gasp. And in my horror and shock and shame, I realize that I edit a local copy of my work.c that lives on my WSL partition, and I did not edit the copy of my work.c that lives inside of this container. This is not great, right? And I'm thinking, no problem. I've got an ingenious plan. I'll create a new container, right? And then we can GCC inside that container. Oh no, because in fact it is not only the container that has the wrong mywork.c. It is the image from which all of the containers are generated that has the mywork.c, because I committed a copy of mywork.c when I built the container. So I have to come all the way back up here, and I have to build it, which means I have to reinstall GCC, which took 30 seconds, right? Now, mywork.c, that solved that problem, right? But I don't really want to rebuild my image every time, right? That seems awful. And so, there's a natural solution, which is we can say, well, where's my cursor? There it is, okay. We can say not low, right? And I can podman copy my work, misdefine, mywork.c to, and now I realize that I don't even know the name of this container I'm in, right? So I think it's B6. So I think I can say B6, I think I do a colon, and then I put it in root or something, right? I don't know what happens, right? B6 doesn't exist. This is a whole hassle, right? So I can use Docker copy, and I could figure out Docker copy. And maybe what I should actually do is say, wait a minute, computers are supposed to be good at things. Why am I doing something that's awful? And so instead of doing that, we're going to do the non-awful thing, which is bind mounts. Bind mounts are extremely cool. So let's use bind mounts. Bind mounts are, I think of them in the following way. They are a technology that was developed by Docker and that I use on Podman. And so the way I do that is I read the Docker documentation, and then I take those exact same commands and I put them at the end of a Podman command. And I feel great about doing that because I'm beefing with Docker, right? I don't like them. I don't even remember why. And it's not important why. Podman's run by Red Hat and everyone trusts Red Hat, right? We went to the Linux thing and the people there were Red Hat people, right? And they seemed nice to us, right? So we're super into Podman. Wink. Are you using Docker in the other class yet?
Just start.
Yes. Yeah. But that's what the notification's about, right? Like, I'm filling your heads with dangerous thoughts over here, right? What is a bind mount? In the olden days, many, many years ago, there used to be things called CD-ROMs. Remember these? Read-only memory? And you would put them in a rotating disk platter inside your laptop that at that time was about 4 times bigger than modern laptops, right? And they'd spin and whir around and they'd play Nickelback, right? And these CDs could be used to do everything from carrying executables that you install on your device, or they could carry bops like Nickelback. There's got to be a band other than Nickelback. Linkin Park, right? Yeah. I'm going to see Amity Affliction, the Sad Boys from Australia, on Sunday, and I've started getting sad already to be ready for it. So, anyways, and in those days, someone realized that the problem is when you insert a physical piece of hardware that contains bits and bytes on it into a device, you have to have somewhere to put it, right? And where would you put it, right? Because all of the bits and bytes on your device live somewhere in the file system, right? And if suddenly some new bits and bytes spring into being fully formed within your file system, they have to go somewhere. And so this became the notion of mounting drives. So you somehow take some bits and bytes and you sort of just like unceremoniously place them atop of your operating system and hope no one is really offended by their presence there. And by convention, there's all these little things like run temp, user var, serve sys, and so on. And then there's also this little thing here called mount, right? So I suspect there's nothing in mount right now. But we can also come back over here to our Linux partition. Does this also have mount? Yeah, this one also has mount. And let's see what's in that mount. I'm putting the slash before it, right, because I'm currently in my home directory as shown by the tilde, so I'm going to reference that I want root mount. And actually, on this, which is Windows subsystem for Linux, that mount has my Windows file system mounted on it. So I have a virtual link directly into the Windows file system, which is located in a physically different location on my solid state drive, right? But I can look at program files. We all love program files, right? I don't have any idea how to use this. There's a swap file. I wonder what pagefile.sys is. That makes sense. Presumably whatever that is I'm not supposed to look at, right? Users, nope. But by golly, I can do just about whatever I want to the Windows file system over here from WSL. Now, I've heard from people that care about performance, and I have seen this a few times, that running the Linux kernel over the Windows file system is quite slow. So don't do any high-intensity programming over it, but that's possible. But anyways, this is an example of where you can take something from one imaginary computer and access it from another imaginary computer. And then over here, I also have mount on my Linux container, and it seems like it would be extremely convenient for me if I could mount this directory right here, which contains my latest my work, which says not low in it. And instead of this old, expired, boring, no longer interesting my work, that says hi GitHub in it, right? It would be nice if I could get those two things to talk to each other, or even just see a new my work through mount. And so we're going to do that. My work latest. Okay. How are we going to do this? I am going to create some baseline container. This baseline container is going to have the things in it that I want. And what are those things? Well, wait, did I run another Podman container? Okay. How many Podman containers are running? That's a lot. Ooh, why is it slow? Whoa, look at that. Oh, I got 2 gigabytes back, right? And they're all gone. So I'm going to just make a container that I'm relatively happy with. Let's see, what should this be? We'll then container file. And I think the only thing I'm going to do is get rid of this line, actually. Wait, yeah, that's fine, right? Okay. We're going to podman build. Should the name of this thing be? I don't know. Not low. And we'll build that over here. Or push to GHCR. What I expect to be the winning alternative to Docker Hub, which used to keep track of every image that anyone ever used, ever, no matter what. I'm expecting the ultimate winning challenger to be the GitHub container registry, which I have never once used in my life and have no idea how it functions, right? The most likely competing thing seems to be the AWS, Amazon Web Services artifact registry, which is not free. But I think everyone that uses containers uses Amazon, so it made sense to them. And then the third most likely claimant to the throne is GitLab, the CI/CD people, the sort of unicorn startup. It's Ukrainian, if you track such matters. They also have an artifact registry. And of course, Google and Microsoft within Google Cloud Platform and Azure have their own container registries, but no one actually uses those cloud platforms, right? So those don't seem likely to be challengers. That said, it looks like I can use Google's for free without giving them my credit card number.
GitHubs?
I believe I can use GitHub's, but not Azure's. And I think I can use Google Cloud Platforms for free without a credit card. But I got kind of sketched out. So like, there seem to be portions of many of these cloud services I can use for free, and I sort of never want to start using some of them because I don't know how long they're going to stay free. Someone with a sort of academic license to these, I'm unlikely to ever get charged because I haven't given them my credit card, but I'm pretty unwilling to start teaching them. And this was a huge problem, and ultimately the reason why I asked to not keep teaching cloud computing. It was just a little too sketchy, even though that is an undoubtedly useful skill, right? It's a little bit too easy to accidentally charge yourself $4,000, right? Because like when you give me access to a bunch of computing cores, of course the first thing I'm going to try and do is like start generating new Shakespeare plays, right? Which that is not free, right? That costs money. And I'm like, maybe we can generate film. And it's like, no, you cannot, right? Like that's, so look out for that. Okay, and so I have a container that I'm relatively happy with. Let's just run it once. Whoa, wrong partition. Okay, podman run it not low. It's got GCC. The GCC has some version, and that's probably good enough for me. Okay, so let's exit this. What am I doing? Okay. What did I click? Oh my gosh. What am I doing? Here we go, container image. Okay. Oh, this container image, I also suggested putting a style in it. We can see cat my work. This is perhaps relatively well styled or not. You can debate that. Vim, my work. I think there's a variety of things you can do that are annoying to this. So I can make this code much uglier and less pleasant. I can save that code. We can look at that code. And this is just an aside. I would like you to be aware of this, especially new programmers that I teach C to and ask them to try and learn Vim at the same time. They can't get any of their indentation right. It's a little bit too tedious. They keep making mistakes, and that's painful for them. So I would argue this code is poorly formed. I'm going to run A-style now. A-style is a old, not particularly robust, but quick tool that styles code for you. We can A-style my work.c. Let's see what that did. And so it doesn't solve every problem, right? But this is a lot closer to standard C style than the first thing I put in. It didn't really get rid of the empty new lines, but like maybe I don't want it to do that. Sometimes I use white space for readability. It lined up the comments with the code. I don't know, it's quite nice. So I've been recommending if you find yourself sort of up a creek without a paddle, right? Writing C inside Vim, right? Maybe you don't want to have a file and folder structure where you have many .c files. That's reasonable. That's annoying to manage. So maybe you have a 500-line C file. Well, it's unlikely you got every indentation in there correct, right? And it's unlikely you even maintained your own consistent style, right? So I'm letting you know about A style. This is just a nicety. And so I put it in here. Here's some examples. So while we're talking about A style, I did not learn about A style when I learned C. I actually found out about A style while I was checking documentation that I helped write for an undergraduate class that I took, that many of these classes are based on. And so I say the people that taught me C wrote this. This is a C style guide. This is the UChicago CS Students Resource Guide. I am sure we did not have this when I went there because this is full of information I didn't know and I would have liked to know. And this is my source for finding out about A style. A style is competing with Clang Tidy. Clang Tidy is the more mature and more powerful A style, but it requires access to the LLVM toolchain, which is hard to install and big and expensive and competes with GCC. So I am telling you about A style, but I'm also informing you of clang tidy. And then there is something called COC on NPM, which is whatever this does. And essentially my understanding is Vim under the hood has the ability to talk to a language server that tells it how to style text in certain languages, and you can install the language server for any given language. Does anyone know what COC stands for? It's famous. Anyways, if you don't want to use A style, use clang tidy or use COC. I don't know how to use either of them. I don't use either one. I wanted you to be aware of them. The kernel hackers have their own style guide, and I wanted to show you one other case where I used a style guide in this class. This was used in the header files description, since I'm introducing that. This is the define guard. This will come in more handy when we start implementing data structures after break. But I wanted you to know that when I tell you to write your header files in a certain way, this is based on the Google C++ style guide. So I am citing my sources for a lot of the style things I'm asking you to do. A style was recommended to me by the people that taught me C, and then this define guard is from Google.
COC apparently stands for Conqueror of Completion.
Conqueror of Completion? I was happier not knowing what it stood for.
I was too.
Okay. That's ludicrously annoying. In my home dev container, I just have these four. And as soon as you finish learning about bind mounts, which we're teaching right now, Vim comes out of the container. So you don't need it anymore, but you probably still want that other stuff in there. And maybe you don't, maybe you only leave GCC inside the dev container with like whatever the package managed libraries you're using are, like libgnp, that's probably fine. Okay, so I made my new container file. I built the new container file. I can just spin up the transient container file, and I've shown that. It's this one container file I made 5 minutes ago. I'm using the Docker documentation, not Podman. Here is the introduction to the mount and bind and volume technology. When Docker first emerged as the container standard, right? Before any of it was open source, before any of it had a sort of stable interfacing with existing file systems, the way to have persistent storage in a Docker container, which was extremely desirable for people that wanted to store, for example, their GitHub credentials, which made it much, much easier to do development inside containers, right? You stored everything you need, your SSH key, for example, which you only want to generate one of, you want to generate as few of those as possible, right? You would store that in a volume. And the volume didn't exist anywhere. It was part of the executable Docker that lived somewhere in Linux space, and it just had some of its own working memory. And so all of the volumes were not saved in the same way that other files were saved, right? They were just called volumes. They were this sort of bizarre thing that was not documented how it worked, right? Everyone hated this. Everyone wanted Docker to pass through and read the GitHub credentials directly off their device, right? And everyone thinking this knew and realized in their mind how annoying it would be at the same time that every single container they ever ran could then see very sensitive personal information on the host device, right? There's no way to make them useful and secure, right? You had to make up your mind. So yeah, in my way of understanding this, what I really think happened is over time people got used to the idea of containers being able to see the host system. And they really began to think more of them as virtual environments, like vend PyVend? I don't actually know how virtual environments work. Everyone uses them for Python because pip is awful, right? But containers really started to be thought of more and more as virtual environments and not as virtual machines, right? And so when I say virtual environment, I mean it has access to its own libraries, but it doesn't have access to its own file system, right? So over the time, the barriers from the host to container file system broke down, but there still remain firm barriers between the OS and these other, the different OSs basically, right? So the only thing the containers share at this time is by default the kernel, and then if you configure it properly, subsets of the file system. These are the different commands. I am telling you that this exists, and I am telling you not to use it. When do you use volumes? Volumes can get super useful really fast when you're running on the cloud. I built a MapReduce container cluster. It ran everything through volumes because the volumes were managed by Google and not managed by the Google file system, which was really cool. It meant I never had to think about what those files were named or where they lived or anything. I just knew every time I turned it on, all of the stored stuff was there in something called a volume that someone else was responsible for. Now I'm assuming if I put in 10 terabytes of information, that would have caused a problem, right? But I didn't happen to have 10 terabytes of information, so that didn't affect me. Anyways, this is the line from Docker. I believe Podman supports volumes and will not tell you that it does, right? They don't want you using them, but they have them there so they don't break. So in general, we prefer mount, and the mount flag / mount can support both volumes and bind mounts, which are the competing form of mount that I'm going to teach you about. Do not use volumes unless you know what you're doing, and none of us know what we're doing. This is the command that sets up a bind mount, and I am providing you with a sample shell script that is located on the crypto repository that you all have access to. There's a few ways to structure this, and what I'm going to do right now is I'm going to not run this exact command, but I'm going to change this thing, the source bind. So, why is that? Here, this is podman.sh. It lives inside a repository named podman that has some sneak previews in it. And this lives inside a repository called crypto. So, when I run podman.sh, the .. is going to refer to one higher level directory. That one higher level directory is the crypto repository. I'm going to run this command, but I'm just going to mount my home directory that contains all of this stuff. Actually, am I even going to do that? I'm going to make a little directory. That seems fine, right? Okay. And what I'm going to do is I'm going to podman run. I'm going to specify the mount flag. I'm going to specify that the type of mount is a bind, not a volume. Volumes are managed by podman. Binds are managed by me. I think I'm smarter than podman. That's not true. I think I know what I want more than podman, right? There's a few options here. I'm going to specify what the source is. The source is which folder on my host device, the device that the container is running on top of, is going to correspond to the mounted folder. I can put a dot here to refer to the current directory, and I can put a % or $PWD to refer to the current directory. Let's take a look at both of those. See, that doesn't do anything. PWD is just a variable that refers to the name of the current working directory. So you will see this show up sometimes in scripts and sometimes not. So you can either use it or not. These are comma separated, so this is a comma separated key set of key value pairs. And then I'm going to say target equals mount. I'm going to mount it to the mount directory at top level in my container. This D flag, I found this interface unstable on Windows, and I was trying to get a consistent interface across Windows and Linux. I have 2 minutes left, so I'm not going to start this detached and try and attach to it, because that's going to take me 2 minutes. So instead, I'm going to start this with an interactive terminal. Interactive terminal. The thing is going to be named notlow, I think I called it. And I don't know that I have to specify bin bash. I think I can just do this. Okay. This created a podman container. The container corresponded to this image, and it had one difference. It also will refer to this working directory, which is ~/temp, because that's where I evaluated it. And it's going to refer to that in mount. Let's check. And there is my work.c mounted inside of the podman container. We will gcc my work.c. Wait, really? Oh, no, well, it's inside mount. I can say not low. But I can do one other thing. I can change this to whatever I want. No. Who keeps typing on my computer? Okay. Why didn't I just save that? I didn't have to exit Vim. I could have left it open. Okay. And I have now linked the file systems between my two devices. And with that, I'm going to go beg the people downstairs to serve me some vegan pizza. And then we will come back and we'll clean this up, and then we'll do a bit of continuous integration, which is maybe the coolest thing that has ever been. Like, it is, I mean, I think bind mounts are like ludicrously awesome, right? And some people disagree with that, and that's okay. Other people are allowed to be wrong, right? But continuous integration is the one thing that is cooler than bind mounts, right? So we get to do that after dinner. And yeah, you can save all your compliments for later. I noticed that you're not applauding, and that's okay. All right, should I stop the stream or not?
You might want to just turn off the capture in the audio.
That's what I this, turn that on. No, don't lock. I don't know how OBS works. So I was talking to one of my faculty colleagues, Professor Rembold, who like knows how computers work, physicist, classic, right? They all know actually. Like, I hate the computers, right? I'm so annoyed they're not just Turing machines, right? And the physicists show up and they're like, this is a cool application of physics. And you're like, oh. Presents off of the OBS, which is like the screen capturing software used preview screen. So like, so what you say, it takes this thing. Oh, that's gonna give me motion sickness. You can like project this onto a second monitor. And so you can do like your own production over here on this screen. And like I could be projecting like something that I'm like doing window control of or something. I don't know, I just show you what's on my screen, right? Which like seems like extremely chaotic now, but I never even perceived them as an alternative, right? Like the chaos was sort of baked in for me. So anyways, that's how I've been living my life. But it does lead to some things. So like every once in a while I go to a URL and I like start typing things in. And like, I don't know what's gonna come up when I type in DFB. So I'm hoping you never learn things about me that seem like I'm really weird, right? Like, what does, I apparently was looking up Dallas Fort Worth.
We see that you have a homepage Reddit to League of Legends.
That is kind of embarrassing. Yeah, I don't even remember. Yeah.
Insightful is the right word.
Yeah, I don't even play. I'm a big fan of sports. Okay, all right, cool.
Esports.
Yeah?
Sports.
What do you mean E? I mean, I'm not a fan of T-sports, if that's what you're asking. The only T I support is T-Swift. Okay.
What is T-Sports? Like professional wrestling?
Traditional sports.
Traditional sports.
Yeah.
Is that like analog bicycle?
Mhm.
Analog acoustic bicycle?
Okay, so I ran this command. I'm living within this command right now. I'm living right now. Quote me, right? We've successfully mounted our acoustic bicycle.
What's a non-acoustic bicycle?
I thought it was a motorcycle. Because my favorite type of guitar is gasoline propelled. Not like Okay, so I ran this command. It's not low. Podman run mount type bind. Okay, let's just step through what each of these things mean. Podman's the container command, you know that. Run is not the same thing as exec, right? This drives me crazy. I don't know what to do about it. It's sort of the same thing where containers and images are ambiguously referred to as containers and images. So for example, in the GitHub container registry, what you store in that thing is an image. Right? It is objectively an image. Like it is the platonic, it is the most image that can be stored anywhere, right? Like it should just be called like photos, right? And I think probably in the fullness of time, everything's just going to be called containers and they'll be called container instances. And I think the image term will go away. We'll see what happens. But the thing that's going to cause it to take a long time to go away is all of these tools have to be backwards compatible. And Podman images is fundamentally always going to refer to these things. And those things are in something called an image repository. And docker.io, therefore, is an image repository, right? But when Docker launched, they called it a Docker repository because they weren't using the term image or container yet, right? So, anyways, everyone hates this. Okay, so run is furnished with an argument, and that argument is the name of an image, not the name of a container. This means they don't have persistent file storage, basically. And it also means that if I install some packages in one of these, turn it off, and then run again, I lose all of those packages, right? Mount, and I think that's supposed to be 2. Should probably be two dashes there. Mount is going to let the container see files that live outside the container. I don't know if I like the word live there. R exist? I don't know. But the point is, files have some location in the file system. We understand the notion of file locations, right? They correspond to file paths. The file path that describes the files that can be seen through mount is, their file path really is something that is not a file path present within the container. Within the container, they have a symbolic or imaginary or algebraic path that begins with the name of the dest. The type bind, I don't know what the other types are. I'm assuming the other type is volume, and I'm guessing there's one type other than bind and volume. My recommendation to you is to use bind mounts or to use volumes. And you use volumes when there's something that makes you nervous about using a bind mount. And the thing that should make you nervous about using the bind mount is, I am going to run something in this container that could cause irreparable damage to files it has access to. Then you do not bind mount, right? And so, yeah, I was going to run a fork bomb. I semi-regularly spin up a container and try and delete critical portions of the operating system, right? It's good to write code that tries to do this to make sure that it can be contained safely, right? Source. I've been using the term host and container. I don't know that this is the most widely agreed upon terminology. I see a lot of references to host OSs, and usually that host OS refers to an operating system upon which containers run, or an operating system upon which a web server runs, right? So the really, really high performance web servers. I want one server rack to accommodate 10 million concurrent users, right? That rack is going to have a host OS on it, and the only thing the OS is responsible for is getting out of the way of the web server, right? But very frequently that's running some version of Linux, right? So I'm using the term host separately. Another place that host shows up, and you might see this in Data 505 soon. So I'm going to go down to Salem in a few weeks, and I'm going to start talking about CUDA. I'm going to talk about GPU acceleration. And when we talk about GPU acceleration, we use host to refer to the CPU, the central processing unit, upon which the operating system lives. And we use device to refer to the GPU. There's a host and there's a device. Neither one of them sort of has primacy, but we need a way to refer to both of them. And we refer in GPU programming. Why do we refer to the host? Because the host is responsible for building, compiling, and running the executables, and the executables schedule and administer the device, right? Not one is necessarily in charge of the other, but one of them contains the first lines of code that are run, right? And so in this sense, I'm thinking of the containers as being something very much like a device. They are a simulated device. They run on the same hardware as the host, but in a way they are different. They have some distinction. They have a different memory space. They have a different file system. I need to run some code on the host in order for the devices to see information, right? So we're going to specify the source directory on the host, and the source directory on the host is going to be linked to some symbolic, some imaginary, but usable destination. This is one way to refer to the working directory. It was actually one of the undergraduates said, why did you say $PWD / ... instead of just ... And then we tried just ... and it also worked fine, which was shocking to me. I thought I had to provide a string, but in fact, you don't have to do anything. There's no rules. Do whatever you want. And so we have demonstrated that here with $PWD, but I'm pretty sure I can grab this thing, nuke the $PWD, and that's probably fine. We ls mount, there's my work, and we can gcc mount my work.c, and we'll once again demonstrate we can make changes. And I don't trust that I did this correctly until I actually see the change get made, right? So I suspect this is correct. I'm going to finish this thought, and then don't let me keep talking after that, but whatever I want. Did I actually make the change? Yes, I did. Okay.
There are 7 types of mounts.
Are any of them interesting?
I don't know what dev PTS is. Or actually, I don't know what any of them are, other than volume and bind. And the other thing is there's an argument to make it read-only, but only if that's a volume, maybe.
Yeah,
Oh,
I
no,
didn't-
and a bind. You can do, there's an RO or read-only, which you can set to true if you don't want the thing to be messing with the stuff on your disk.
Okay, I do want to do that. So I'm going to specify that as part of the key
RO
values.
equals true, I think.
RO equals true.
Yeah.
Okay. We're going to do both things. I'm going to attempt to edit a file on both. I didn't put them in here. Oh, we're in Alpine. Okay. Ooh, that was fast. I thought we were going to be here for a while. Okay. Vim mount my work.c.
See where it says read.
Yeah, read only. That's cool. How robust is it? So
There's another option called chown, which will just change the owner of all of the items in the mount to the user of the container.
that seems really bad.
I agree, but it's very fun. I'm just looking at the man page entry for Augmented.
Read-only file system. Okay, that's cool. All right, so we verify that that's read-only. Now let's turn read-only to, or we just remove it, right? Cd into mount, vim my work, and then we say hello from Alpine. We can, of course, GCC my work and then IU'd it. And then we can also cat my work and see that we are editing the external file system. What this means, of course, is that I can delete that file from inside of here. Which, do I want to do that? Yeah, sure, why not? It's easy enough to, well, no, okay, I don't want to delete that. I don't want to type the boilerplate again if I have to. Okay, so I guess my recommendation is to do read-only and, oh no, that makes sense. We should probably use read-only mounts, I'd assume.
Unless you're going to be editing code in your container.
Yeah,
Which, while something they aspire to, is also like deeply deranged.
I mean, it's a little bit deranged. Isn't it also like, we can agree it's kind of cool, right? Like, no, this computer, I don't write code on here, I only write it in containers that are mounted on my host OS.
Opening my lunchbox and full Tupperware.
Yeah. Okay, blah, 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 stepping through. You can use PWED scripts, and so on. I think you can't use it on Windows, right? Wait, do I have a Windows terminal open? No, okay. Does this work? Oh, that's cool. Then if I switch to command, then I think it doesn't work. No, oh, it's dir, and it's $. Wait, what? Volume?
That you don't have a variable called PWD.
Yeah, but I think I have one called CD. I also just accidentally zoomed in. I don't know if I meant to do that. So, anyways, you can do this in, how do we get, is that get back to PowerShell? Sorry, I had to use 100% of my brain to simulate 3 OSs at the same time there. Because, in fact, even before WSL, Windows was 2 OSs because it had 2 different command lines, and like that's what makes you an OS, right? So we have the PowerShell, which I believe PowerShell is the .NET command line, right? And then we have command, which is the DOS command line. And Microsoft saw this, and they're like, we should standardize our command lines by adding a Linux command line. So, good for them, you know? Okay. So here's the sample. Nothing here too complicated, I think. Let's make this a little bit more exciting. So, I have an A dot out. Wait, really? I can't run that? Why can't I run that? What am I doing wrong? I thought that's how I run commands. Let's see. I mean, I can't.
Which is where the A.out is living.
Yeah, but it's back on the host, right?
Yeah, but I don't think you'd ever made the A.out in this directory.
Is it different A dot out in this directory? Okay. Okay, so we're going to remove A dot out. What do I want to do? We're going to GCC inside a container, compile inside that container. Okay, so I've got my work.c. Okay, we're going to make that a little less heinous. Then my work.c. That's fine. Okay. Okay. Blah, blah, blah. We made it. Okay. I'm going to, and there's two ways to do this, but the way I want to do this is I'm going to try to write a command at the command line that spins up a container, attaches to the local directory, compiles something, and produces the executable output in the current directory, and then goes away. So this is going to be an atomic single run container that runs a single GCC command. And I think the way I'm going to do that is I'm going to podman run mount type equals bind source equals dot. It's not dest. What is it? Target equals. Yeah, why don't we just put it in root? Is that dangerous? That's probably a terrible idea, right? I really want to just put it in root. I'm not going to try. I'm not going to try. But I want to try, Ari. Don't shake your head at me. It's fun. We're having fun today. Okay. Fine. I'm going to put it in mount, right? It would be a lot cooler to just do directly to root.
I don't know what that would do.
It doesn't matter. I'm like quadruply sandboxed.
Let's try that.
I don't know why I'm listening to you. Okay. Okay, I'm going to run that with mount. I'm going to run the not low image that we made. And I'm going to, I'm unwilling to do this. That's okay. I'm going to GCC mount my work.c, and I'm going to output it to mount my work.out. I forgot to do the name of the image, and the name of the image is not low. Ah, so close. Okay. No, it's there. So why are those things there and I can't use them? They have to have the wrong permissions, right? It says no such file directory, but the file directory is right there, right? What am I doing wrong? I don't see it. I don't see what the problem is. Because there wasn't something previously called my work.out there, right? It's listing a file there, but I can't reference it. Can I cat it? Oh, it's physically there. There definitely is a file by that name. Is there missing characters? I even got this to work 48 hours ago. What am I doing wrong? What's the example say? what command did I run? I ran this command. Can't figure out what's wrong with it.
Is it the wrong type of executable? That's what Stack Overflow says it might be.
It is. It's not enough. The difference is, no, I just realized what I did. When I got this to work, I cross-compiled it on Ubuntu. This is an Alpine executable. I can't run Alpine executables under Ubuntu. Not to worry, I have a plan. We can fix this. We're technically, we do consider ourselves intelligent people. And the manner in which we're going to be intelligent is we're going to modify our container to be an Ubuntu container. We're going to compile an Ubuntu, and there's going to be an Ubuntu executable left on our device. And then it's either going to work or I'm going to eat my hat, which I did not bring in, so I'll bring in a hat in 2 weeks and I will eat it. Okay, how are we going to solve this problem? I have a container file. That says from Alpine. Ubuntu. Hold on. I might have an awful idea. There is a GCC image. Is it on Debian? I'm going to resist temptation to try and get a Debian image to run on. Okay, this seems like a bad idea. I'm cutting myself off. We're going to quit while we're ahead. Okay, right? We're just going to get this to work. We're not going to do anything sketchy. It's going to be a little sketchy. I'm in insert mode. Okay. Run apt update and apt install GCC. Is that all I need? Podman, Bill, duh. Okay, T, yeslow, dot. This takes like 10 minutes because like Ubuntu is like a real operating system. It's like actually used for things or whatever. I don't know. I personally do all of my development on Solaris, so I don't use any of these operating systems.
You don't use CentOS?
No, it's too expensive. I use LibreOffice. Isn't that bad enough?
What was the other alternative OS while we're still waiting for this? Oh, never mind, too late.
We tried. Firefox OS?
Symbian.
Symbian? Yeah, there you go. Okay, so I think I think if I just change this thing from not low to yes low, then it's fine. Oh, okay. It's not hello from Alpine, it's hello from Ubuntu. But, okay, for the record, okay, let's demonstrate this again so we understand how cool it is. Okay, I have a .c file, right? I am not going to use GCC on this computer. This computer is already an imaginary computer, right? This is a VM running on a Windows host, right? I'm gonna press the up arrow a few times, and what's this gonna do? Podman is going to run from an image. Which image? The yeslow image. It is going to run with a certain series of commands. It is going to run with a mount command of type 5 that is going to map this current directory, named dots, to the mount location. It's going to run yeslow, which I previously defined. When it turns on that container, which corresponds to the yeslow image, with these additional considerations, it is going to execute this command. This command is going to compile the mount /mywork.c, which corresponds to what? This mount, which corresponds to what? This location, which corresponds to what? One of these things over here. This one, right? Which is at the current location. So this mywork.c refers using a relative path to this same file, but from inside of the container, right? And then it's going to output. Where is it going to output? It is going to output to the same relative directory, but it's going to output something called mywork.f. So when I run that, I'm going to go from having no my work to having yes my work.out. See, the file shows up on the host device. And if I compiled it under the same OS, it'll be able to run. And I know what you're thinking, right? You're thinking, wow, you should do this on Windows, right? Because that was immediately what I thought as soon as I got this to work. I was like, well, I mean, if I'm all powerful, right? And I think you can do this, so you can still run it. An astute learner will notice that I'm extremely nervous about getting something to run across operating system boundaries, but I think, we're so close.
You put in close my work.
You think,
Full commands with both of them.
oh, you think the semicolon's getting kicked back up to the current OS?
I know the semicolon is what's getting kicked back out to the current OS. See, now that this error is coming from bottom.
I feel like this is like a quit while we're ahead angle. Okay, so we'll quit while we're ahead. Remember a long time ago, many minutes ago now, we were over in a Windows partition. Do you remember that? Wasn't that fun? Let's see. Maybe we were in documents. Look at that. I'm typing.
All I see is the, data set.
Yeah.
I have a need to predict provinces.
Okay, where's the Casablanca Valley?
Casablanca Valley, isn't that in, that one's not the one in New Zealand, is it? No, that's Marlborough.
Mm-hmm.
Isn't it Oregon? Was it not Oregon?
No, it was not Oregon. Oregon was its own thing.
That's right.
Yeah, Oregon has.
It wasn't necessary to know, we still won our class.
It's in Chile.
It's in Chile.
Yeah.
Oh.
Yeah.
Never thought to look.
Yeah.
I don't remember in Marlborough.
This is. I made the students do a geography quiz in Salem. I was like, "You're from Salem. You need to know about the rest of the world." I didn't say it that way. I said it a much nicer way. If you're listening on Zoom, that's not what I said. Okay.
If you're listening on YouTube Live, put in the chat what every word you can think of that is a geographical term from Napa Valley. I want to hear about the Russian River and Sebastopol spelled incorrectly.
Wait, hey, I have a container file here. What's in that container file? Hey! I have a lot of container files on my device. So perhaps you are devious, conniving, or even scheming. And perhaps you really want to use GCC on Windows because you don't have a lot of hobbies, right? Well, let's remove new thing.out. I guess I'm supposed. Should I change the theme back?
We could do the other light theme. It might have a less.
Settings. No, that's not. Yes, that is it. Color schemes. Set as default save.
It's slightly better.
It's pretty bad though.
Well, it's the operating system's fault for putting things in bright light.
Here's the deal. I'm not going to open Vim for a while, so let's just go back to PowerShell.
Accept it.
Oh, that is disgusting. Okay, let's, what? Solarize Dark? Ooh, yeah, there we go. My favorite. Feels like I'm using a good operating system. Okay, all right. Okay, so new work. Okay, container file. You know what? Actually, do I just have this ready already? Why do I have Fedora? Look at that. I just have a Fedora image there. So anyways, oh, maybe I couldn't get container files to run or something. Well, okay. I'm going to. I don't know why new work is called that. I don't know why new work is called that, but we're going to try and print something else. And the manner in which I'm going to do this is I am going to have to use detachment. But what I'm going to try and do, I'm going to try and launch an Alpine container. I'm going to launch it detached, and I'm going to launch it mounted. I'm going to throw a compile command into the Alpine container, and then I'm going to throw a run command into the Alpine container. And I'm going to do all of this without transitioning my command line over to be within the Alpine container. And that is how I'm going to try and run C language executable compilers under Linux directly at the Windows command line. I can probably do this without my reference materials open, so that's not what I tried to full screen. Okay, so podman run. I'm going to run this mounted. I am in, wait, no, we have to do something first. How do I refer, did this work? I think I can use PWD, right? Okay, so we're going to podman run. I'm going to use a mount. I'm going to use a bind mount. I'm going to attach the source, which is, I'm just going to say PWD. I'm not going to try dots and not dots on Windows. I don't know how that stuff behaves. It should behave the same way. Should I try it?
Sure.
We'll just throw a dot here. Okay. Target is so weird to me. It's called target and not dest. I always see source and dest. Mount. Podman run mount type bind. Okay. I think that completes the mount setup. We are going to do read only equals true because I'm going to see if it works on Windows. It was RO equals true, right? That look? Okay. What does detach do? Detach is going to start this container but not transfer control into the container. So it's going to be running in the background. When it's running in the background, I'm going to be able to issue commands to this container. I need to do that because I'm going to need to use more than one line, and I haven't figured out a clean way to transition lines indirectly. Of course, I could write a shell script file and inject that and run it inside. It's getting a little sketchy. So I'm going to start this detached, and I'm going to start it of type Alpine. I think that's fine, right? That looks okay. Okay, so I have an Alpine container running. I'm going to podman execute. I'm going to just do the first two of that. I'm going to assume there's only one 5.8 container. I'm going to apk add gcc. Okay, it only works on running containers, which means this container is not live. Okay, not to worry, I have a plan. I'm having it run shell, which I think is persistent, so it should be waiting for input that it can't receive because it's running in the background, so I'm going to hope it's live. Oh, that's sad.
So if you were to do like just for curiosity, podman ps-a, that would show that it is open and closed already.
Yeah, they're all there.
Whoa. Look at that. How long ago you closed it?
Wait, which one?
The top. How long it's been closed, its status?
Top.
Yeah.
That's probably wrong, right?
I think that sounds reasonable.
Because it was created 2 days ago.
We see the first time container is from time travel.
That's somebody.
Okay,
Somebody detached it.
so how am I going to keep this thing alive? Wait, no, I have a plan. I'm going to leave it open here, and I'm going to open a new command window. There's probably a good way to do this. Do I know what it is? Do I look like a software developer? No. It was odd that none of you said, yes, Calvin, you look like a software developer immediately, which is what I was kind of expecting there. Right, yeah, okay, sorry. Do I look like a software developer?
Yes.
You're bad liars. Okay. We were in. That's like. What would it be other than application program interface? I don't know. I'll work on that. I'll have a bad answer for that soon. I have to do CD. Oh, documents plural. Okay. Right. So I have a Podman container running over here, and that's actually nice because we can like see what's in mount and stuff, right? So in case you're not sure what container file is from there, I did this really cursed thing that I think is actually super fun. So this is documents work. So I liked the idea of being able to see how cursed the Windows file system looks from the command line, right? And so you can just copy paste files and like look how hideous that is, like space dash space copy. Like, who designed this operating system, right? That's so weird. Like, it's just a weird way to do things. But anyway, I thought it was cool that you can do these things in sort of the graphical user interface, and they show up under Linux, right? Kind of cool. So, okay, we got that going. I am going to podman exec. Nope. Podman piece. One of them is running, and it's CA. Podman exec CA GCC mount newark.c. And I am going to direct its output to mount newark.out. I wonder what Newark stood for. There's like an airport in Newark, right? Okay, the executable is not found, so podman exec ca apk add gcc. It's going to install gcc quickly, and that's not going to be enough. I'm also going to have to do libcdev. Probably. Well, that was fast. Read-only file system. No, I did it read-only. Okay, so how do I deal with this? Do I have an ingenious plan? No, I don't. I don't know, that's kind of the same thing, right? So I'm able to compile, run, and use C language executables within Podman from the Windows command line. And you can also do this from command instead of PowerShell if you want. I've provided you with scripts that do this because I wanted to get them to work. So fun fact, this is mostly a funny aside. I showed this on Tuesday in class, and it showed extreme seasonality in Windows. And that's because I made a mistake. And the mistake I made was I was comparing Window to Linux. And Windows have seasonal search terms, right? Because people look up Windows at a certain time of the year, or look up Window at a certain time of the year. So you actually have to make sure you specify Windows, and then you see that both operating systems were roughly equal in popularity, but coming down much over time, right? I saw a graph today that I don't know if I believe because I didn't see the underlying data, right? That suggested something like below 10% of Microsoft's revenue is coming from Windows licenses now, which is unbelievable given the history of that company, right? And over $250 billion are coming in just from Azure, and Azure is not most of the cloud, right? So that was pretty alarming, and I don't know what actually happens if I compare Windows to Azure. I'm guessing no one actually looks up Azure, right? But it's trending up. So the derivative's quite different, right? This is tough because it's also the store, right? But I don't know. That's historically interesting. And what happened in 2004? MapReduce. So that's when the cloud platforms launched. Whatever else Amazon is doing, right? Mostly they're a mall on the internet, but in fact, the mall on the internet only works if you have cloud services, right? So that's how they got misclassified as a tech company. So there you go. The reason this still goes to Windows Linux is I changed the API call, but not the URL. So, hey, API mentioned. I'm hired. No. Okay. Windows has 2 command lines. Don't blame me. I voted for free and open source software. That's not true. You're not allowed to vote for that. It's not on the ballot because no one wants to hear from people who like free and open source software. Okay. How does Windows work? Pick one. It doesn't. I don't know. That is funny. So, anyways, I got the running scripts to work in both PowerShell and that. I don't know. This all works fine. I'm losing interest here rapidly. Presumably I can refer to WSL images from the Windows host. Right. My device, which I'm assuming is standard, the right-hand side of my screen is in WSL, and how do you tell that when you do ls, lists in one line? The left-hand side of my screen is in command, so ls is not supported, or I can switch to PowerShell. I can't believe you have to type the whole thing. And Windows assumed that I wanted to see all of this text. Thanks, Bill Gates. I needed all that there. Without that, I was going to be confused what ls means, right? But there's another difference, which is that, in my case, my Podman image repository, which is what I'm going to call this, does not have the same images on Windows and Linux. And I actually like a way to get those connected because I very rarely care under which OS the image was generated, right? I usually, speaking, want to have them. And I think actually the solution to this is I need to put them on GitHub Container Registry and just not use anything locally. Everything should be on the internet. Because in fact, at home, I have a desktop that I do development on, and it should be using the exact same images as both of my partitions. So I think that that's a solution that I need to come up with over time, but it was interesting to me that if I were the designer of Podman for Windows, if I detected a WSL install, which Podman will ask you to turn on WSL before it installs itself, I would have connected these two things together. So perhaps that is a someday thing, perhaps that is a no one actually uses Podman on Windows thing. I do think the Windows people like Docker a lot better. I think Docker seems much more stable on Windows. Okay, this is how you launch a container, blah, blah, blah. It is possible to install Vim on Windows, but I don't actually remember how to do it. So I can't demonstrate that right now. And I think that's everything. I'm assuming you don't want to do this exercise, so I'm going to move on to CI. Any questions on bind mounts? They're cool. They're very cool. And in addition to being cool, I needed one excuse to live code an unbelievable amount of containers because people were getting confused by them. So I hope you all enjoyed watching me try and get containers to work for 2 hours. I use containers for fun all the time. The other day I just started a container inside another container, not for any reason. I just wanted to feel something, right? And so there I was. Okay. No, didn't feel a single thing. Yeah, so apparently, and I haven't tried it yet, if you have a version of Windows Server 2003, for some reason this thing can run inside containers. And so as soon as I heard that, I've been really trying to launch Linux from inside a Windows 2003 server container from inside WSL inside Linux, right? Or inside Windows, right? Because that's the recursive operating system. Because as soon as you can go Linux to Windows 23, you can run Docker, probably not Podman, on Windows 23. And then you can run Docker for Docker inside Podman inside that Linux container, right? Like that would be So cool. And I really do just want to write the script that sees how deep my stack can go before the computer topples, because these containers are supposed to be relatively lightweight, right? Like maybe I can just go 1,000 deep before I get really high performance costs, right? Because it's just going to start writing stuff to the hard drive. I don't care about that. I've never even once written to my hard drive on purpose, right? So that's my great white whale, is the mutually recursive operating system stack. What am I going to use it for? To try and feel something, right? So I got a lot of negative feedback. I just gave this lecture in Salem, and I'm going to do GitHub Actions before Make. But to me, Make was a more basic technology, so I listed it first. But I'm not going to go chronological order, right? Make came out in 1976, and GitHub Actions came out in like 2018 or something, right? So I can't list Make after GitHub Actions, right? But I'm going to introduce GitHub Actions to motivate why we're doing Make. Do you all know what Make is already? Okay, so
it takes a really long time to run when you're installing something with Homebrew.
you're not wrong. So I sort of expected all of you to kind of know what Make is, which is fine. I have no idea who doesn't know what Make is, but I might have to just teach you more Make. We'll see how far we get through it today. But separately, I have to teach you GitHub Actions. Do you all know what GitHub Actions are? Okay, so maybe we actually go through that faster, and then we can talk about Make a little more. Make it's from 1976, and it's still used. Like, that's so weird, right? Like, it's older than C89. Okay, so last class, before dinner, what time is it? It's 9? I took a lot of psychic damage when I saw the time there. Okay. So here's what I like about bind mounts. They're awesome, right? I think we can all agree they're extremely awesome, right? Here's what I don't like about bind mounts. You have to type 4 key value pairs, comma separated, without making a typo. And I'm not gonna pull up monkey type because I just looked up what time it is and I'm stressed out now. You never really want to be typing commands that long. Here's another example of a command that's pretty long that you don't necessarily always want to be typing. How does GitHub work? Git cd ca9 crypto. So here's an example of a long command. Wait, is that? Where's the thing I say to compile from? Oh wait, no, this is not the one I mean to be in. I mean to be in action. So, spoiler alert, this is my SHA reference solution. I'm assuming you've either worked on SHA or major piece with it by now, but I'm going to show you my solution. Tis but a jest. Okay. This thing is long. That's long. I don't know what all of those are. I added them one at a time over the years, and I don't remember what they are. I cannot type that. I can only copy paste it, right? And that's bad. Why am I using my brain to remember things when I have a hard drive, or even better, a solid state drive, or even better, random access memory, or even better than that, a GitHub repository, right? So I should never remember this ever again. Why do I remember type equals bind, comma, source equals dot, comma, target equals / mount, comma, RO equals true space? That's a weird thing to know, right? I could have used that brain to think thoughts or feel my own feelings, right? And what is this I trying? All of these commit names are hilarious. A bunch of nominal changes. Okay, so I'm going to close mount. That's awful, and so we need a solution to that. I'm going to go on an unrelated tirade about CI for a while. So, in my line of work, what am I doing? I'm going to ask you what you said in a second, but right now my brain's melting.
The only other option is politician.
I usually describe my job as late night. Like, I learned a lot from Johnny Carson, you know? I'm frequently confused with David Letterman. That's, people come up to me on the streets and say, "Hello, Mr. Letterman." And I say, "No, sorry, I'm actually Calvin Deutschbein. You probably confused us because we have a similar-sized YouTube following, right?" Like, comment, subscribe. Okay. So on one of those like consulting gigs I had once, right? We were talking about CI/CD pipelines or something to that effect. I don't know. And there was this person who I guess like works for a real company that has to make money, who kept saying build, test, deploy. And I was like, what's build, test, deploy? Why do you test your code? You just push it straight to live and you just hope, right? And then I was, I was in Salem the day the Board of Trustees kicked us out of our main classroom, and a student found one typo. And so I pulled down the full course website repository that has like the advising system on it, has all my historical courses. It's not factored very well because I just started throwing stuff in there, and then I taught like 15 courses, and it should all be factored out now, right? And I ran Quarto render, because I have all these Quarto markdown documents I use. I don't know what it did, but somehow I corrupted a YAML file when I downloaded this repository, probably because I like pulled it to Windows off of Linux or something, right? And every single web page broke. And I like didn't even get an email from GitHub, right? It just pushed that thing straight to live. And then I came up here, and presumably I looked really stressed out one day, I don't remember, but I had to rebuild the entire website before I started class one day. And I don't know if I told you this or something. Anyways, so it was in that moment I realized that I still shouldn't test my code, and I should just be even more fearless and unapologetic, right? That's what I realized I should be doing, right? Because only a coward would not just present off of any given markdown document at any given time, right? So anyways, there's supposed to be something in between here that says test, right? And mine says report build status. But when Quarto fails to render it, it doesn't like throw a fail, right? It's just like, guess you hate formatting. That was a weird design decision, but you can do whatever you want, right? So anyways, this is build deploy, and it's supposed to have build test deploy. Do I look like a software developer?
Yes.
So anyways, right now I'm going to show you build test. And build test is what I'm going to encourage you to use in this classroom, or in this classroom, this class, this course, right? Build test CI for C. So CI stands for continuous integration. My impression is at some point in the past when I was interviewing for tech jobs, I remember interviewing at a place called like Viasat. They like made satellites or something, right? They're like, do you write a bunch of unit tests? And I was like, no, I just write code without bugs in it. They didn't like that very much. And then they're like, what about integration testing? I was like, sounds like a good idea. Never tried that. And so they offered me the job, and then I turned it down because it was in Java. But, and so anyways, historically, the examples I think of is unit and integration testing. And then, in fact, there's build testing. And I'm more accustomed to build testing when you're building the operating system that's going to go on a car or a train or a nuclear power plant, right? But in fact, building has become more and more common over time. I am accustomed with the modern approach. Build, test, deploy runs on some remote server somewhere. And in fact, that remote server can be managed by your IT people, but it's probably not. It's probably managed under the infrastructure as code paradigm, and some developer wrote what the build server was going to do, and they described it by specifying its operating system and what commands it was going to run. And then they separately went and developed a bunch of software, and the software is built on the build server and so on, right? My impression, the way this has been described to me, is the people at Google, back when Google was a company that was good at this sort of thing, and they seem to maybe not be anymore. This was pioneered at Google, and it was called site reliability engineering. And it is still, to me, this day, unclear if site refers to website or the physical location that these data centers were running in, because they were concurrently doing reliability for both. Site reliability engineering had terrible branding and has now been referred to as DevOps. But Google put this together when they were going through their rapid growth phase, and they just had to keep the website online no matter what. So they had engineers whose job it was to keep the website online. Not to make sure it was good, not to make sure it works, to make sure it doesn't go down. And they came up with this build, test, deploy, test stack, where on some remote server somewhere you specify what causes changes to the software running on the server, right? This seems to work really well. To my knowledge, Google has never had 1 second of downtime on their primary search functions, right? I do know that there are times that the internet has gone down, but not all of the internet has gone down ever at once, and never all of the regions that Google was active in have gone down at the same time. That could change someday. Seems unlikely at this point, right? There's just so many data centers that I think, like, even if access to the data centers went down, you would assume that internally in the data center there's still processing going on, and they're still maintaining clocks and things of that nature. I think of CI as being a component of CI/CD. Everywhere I've seen it, well, when I was looking into this, it looks like people always mean continuous delivery when they say CD. I was not accustomed to that. I thought it always meant continuous deployment. So that was a little bit surprising to me. I don't think it matters. CI is the code that is written in text, right? Printable characters, a human typing a keyboard, checks that into a repository. And then something happens in the back end. And then some software as a service somewhere changes. The software as a service somewhere changing is continuous delivery. The code actually working is the continuous integration, right? So no change should show up, but mostly what should happen is your site shouldn't go down. If someone checks in a commit to the repository that is a breaking change, it should simply not deploy to live. There should not be an arrow directly from build to deploy. There should be one that says test, and if a test fails, then the test should not, that tested branch should not deploy to live. So I am imagining that the platonic ideal of software development in 2025 is there are a bunch of developers sipping their lattes, working from home. The manager's going straight to voicemail. Maybe they're like playing a little bit of Subway Surfer on the side, right? Just an idyllic, peaceful life, right? Probably like a cat. We some cat people. Okay. And you just clickety-clack away at your computer. You close your Vim window, because you better not be using an IDE. I better not see any IDEs, right? Okay. You close your Vim window, or perhaps you just switch to another terminal. You just git commit, git push, and far away there's some happy whirring of a data center, and some new service goes live that makes the company a whole lot of money, and you get 1% of it, right? That's the life I want to live, right? And in fact, that's what I do. I do CI/CD teaching, right? So that's what I'm imagining we want to do. And I think of this working in two contexts. I really think of this as software as a service, right? Really think of this as pretty much every day Gmail or Google Docs changes, right? Google really, really doesn't want me to download any of their code as a program unless it's Chrome, which is interesting, right? That gets me thinking about what's in Chrome, right? But in general, this also works as packages, right? So anything under APT, which is maybe the advanced package tracker for Ubuntu, right? All that stuff is sort of continually deployed in some sense, where there's just a web server somewhere that has all the bits that correspond to those binaries on it. And anytime I send out a little APT request, I get the fresh stream of bits. But in fact, they could patch what that binary is at any moment, and I wouldn't know, right? It's continuously being served, right? So perhaps that is continuously available for delivery, right? I think very highly of this methodology because always having the version of something that works is appealing to me. Let me just give an example from my own life. Some of you have realized by now that I am an assistant professor of computer science. And sometimes we make changes to the computer science curriculum. And sometimes we make breaking changes to the computer science curriculum. And, do I want to say this? Okay, last year, after the last day of undergraduate classes, we did not agree on how many courses were in the CS major. Not which courses. We didn't have a number yet, right? And so this was stressful to me because I thought we should not have pushed to live if we didn't have an assert statement that was guaranteeing that we had an integer number of courses required for the CS major, right? And I have remained angry about this since that moment, right? So I have been trying to subtly suggest to my colleagues that we should use CI/CD development for curriculum. And we just don't push changes to live if they don't pass the test of, does this have an integer number of courses in it, right? And I know what someone's going to say. They're going to say, why integers? Why are you allowing negative numbers of courses? And it's like, I would have settled for that, right? I would have settled for the negative number. So I think CI/CD is, as with many elements of the sort of software stuff, this is probably actually a systems development lifecycle technology. I suspect it will take some time for it to go from software to systems. But Waterfall went from software to systems. Agile went from software to systems. My partner makes doos that go on silicon wafers, and they do Agile. None of them know why. I think they might stop doing Agile because none of them know why, right? But like, it is in fact possible to make goo that goes on wafers under the Agile methodology, right? And my assumption is that at some point, large amounts of the physical and chemical sciences will be heavily automated using robotics, and probably that stuff will go under CI/CD at that time, right? Where someone will sit at a computer, sip their oat milk mochaccino, sit it down, write a few lines of code. In the distance, a robotic arm will whir and spray a slightly different hue of goo onto a slightly different sized silicon wafer, and then some robot will look at it under a UV light and see if it has the proper performances, right? Like, I'm assuming that's the way science is going. I saw a very intriguing post on X, the Everything app. Never said that out loud before, it does feel ridiculous. The current sitting US president got into a Tesla car and said, and I quote, "Everything's computer." And I commend the president on a spot-on analysis. In fact, everything is computer now, right? Some people, do you remember, any of you, perhaps when you were much younger, there were phones, and now there's computers, right? Yeah, the rotary, yeah. And when I was a kid, we just had to yell into the cups that had the string on the end. That's what we had. And so, yeah, like everything's computer now. And so as everything is computer, ways that solve problems for software increasingly solve problems for other things. And so the example of this is in my first job doing human spaceflight, right? It was, well, mostly our job was to write the piece of software that makes sure the rocket goes to the moon, right? And sort of everyone already knew how to get rockets to go to the moon because the Apollo program did that, right? We just had to make sure that everything the Apollo program did was written down. And we wrote it down in C89. Okay. I bet they used, well, they couldn't have used C11 because it wasn't out yet. I bet they used C99, and I just didn't notice. But we had 32-bit words. We did not have the 64-bit words. They were using this is probably secret, an EF750 PowerPC processor, which was older than 64-bit words. So, oh yes, okay, right, my unhinged tirade on software development, right. So, my internal narrative, and everyone loves this, absolutely no one considers this controversial, is that Java started becoming really popular in 2004, and then the world economy experienced its greatest recession since the Great Depression in 2008, when everything switched over to Java and stopped working, right? And basically, economic growth in the United States, in my view, stagnated since then. We continue to see, you're an economist, tell me if this is wrong. We continue to see growth in the upper sectors of the economy, but purchasing power for working people did not increase in that time frame. And then in 2020, everyone got sent home from work, and all of the software developers would rather quit than continue to write Java, and they invented Scala, Rust, a few of these other languages. OCaml exploded more. And a lot of people refused to come back into the office, and what they switched to doing is they stopped writing Java under Agile, and they switched to writing some of the more functional languages under CI/CD. Coming out of that, the US saw its most rapid economic growth in decades, while people weren't coming into the office and many people were out of work. Now, 5 years later, every single trillion-dollar company in the world is either an oil company or a cloud company. Perhaps all of this is a coincidence, and I will never believe that ever, so don't try and convince me. Thomas, is that correct?
Sounds about right.
Sounds spot on, right? Like,
I'm not an economist, I don't know.
I thought you studied economics.
No.
Real?
No.
What did you study?
Data science.
That's the same
I had
thing.
a singular data science major, however.
Really? Do you know any economists?
Like in,
That's crazy. Was someone else in here an economist? Are you an econ?
I have an econ minor.
An econ minor? That'll do. Okay. Did everything?
And, the only thing that I didn't check out is that Scala's from 2004.
No, Scala's not from 2004. Yeah.
It is.
Real?
Just Googled it. Yeah.
Okay.
I should check the date.
So Scala was from 2004, and Hadoop came out in 2008 in Java.
Yeah, 2004. Big agrees.
Well, it's Bing the everything app. Is there a name for Bing? Does Bing have a subtitle?
Microsoft Bing.
Microsoft Bing. All right.
So like the R project for statistical computing.
I love the R project for statistical computing. Yeah.
Microsoft Bing project for finding things.
The Microsoft Bing search engine. Okay. I'm sorry I didn't know you were an undergraduate major. I don't know why I thought you were an economist. I hope you didn't interpret that as a vicious slander.
more, I mean, no.
The survey's out, right? Okay, so you're all around for DeepSeek? Free? Yeah, like free and open source. Put Sam Altman in the ground, right? We all probably hate him. We don't actually know, right? We just assume. So anyways, it looks like the Chinese tech industry is converging much more strongly on free and open source. And the United States went through the same thing, right? So Microsoft maintains 2 operating systems now, and one of them is Linux, right? So it's just how it is. For whatever reason, no one can compete with free and open source. My claim is that CI/CD has been provably verified as the correct way to do things by the quality of the Linux kernel, which was maintained public and continuously available through a variety of technologies. First, it was maintained through tarball access on privately operated but publicly available web servers where there were tarballs of the Linux kernel, and then later it was put onto GitHub. And now currently, Microsoft Windows, which tried for 2 decades unsuccessfully to kill Linux, now the sales of Microsoft Windows are used to keep alive these servers that the Linux kernel is hosted on, which is a great twist of fate if you really, really hate tech companies, which I do. This is why I can't get a job, by the way. So both Windows and Mac are sponsored by trillion-dollar companies, and they don't seem to have achieved the same level of code quality as either Linux or FreeBSD. FreeBSD has fewer functions, has less functionality, but is even fewer bugs, right? And I would also like to mention, this was heavily contested when it happens, but in fact, the Linux kernel has maintained purely imperative. It is not under object-oriented design. Object-oriented design is one of the sort of software engineering methodologies, and object-oriented design has also been promoted to systems design level, though it is less popular there because objects kind of can't exist in real life, right? That doesn't quite make sense. I can't have multiple instances of an orange that have the same function. That's a little bit strange. And so Linux was developed without the presence of managers, offices, or sprints, or objects, right? This is interesting to me because every time I interview, they ask me about managers, offices, sprints, and objects. And I say, well, the best code doesn't use those things. And this is how you become an academic, because no one actually cares, right? So here are some things that I consider to be maintained under something approximating the CI/CD model. Yes?
What do you consider files to be in that paradigm of yours?
Files?
Yeah, in reference to Linux.
So I guess files are so interesting to me because they're one of the systems to design methodologies that predates computing, right? Because they correspond, file systems predate computers, right? And I've never really come to my conclusion on how I want to think about them, but one of the examples I give, and this is the thing that has caused me to say I don't know what to think about files. Because the file systems in computers can contain symbolic links, I can have an infinite file system in a computer. And I can have that with finite storage, because it can have loops. And that causes me to like just not be sure how to think about files, because like that's just like fundamentally a contradiction that you can have a file that contains itself. And usually you can have a file that contains itself depending on the opinion of the operating system, which to me means we haven't answered the fundamental computing problem of what is a file. Because it seems like we should first have to be able to answer whether they can be infinite or not. And I just don't know how to think about them. I do think, and like maybe this is as close as I can get to anything, to me, the object-oriented paradigm emerged specifically to solve a problem that I call like the one higher category problem of encapsulation. And folders, not necessarily every file, but certainly folders, are a methodology for resolving encapsulation. In the undergraduate program, we teach classes in Python, and we have them write one class per file, which means we have one class per module, because Python files correspond directly to modules. And I can't figure out why we don't only teach modules. And so maybe this is one way to think about, like, are files a more, to me, feel a more logical or rational or tactile way of understanding encapsulation than objects? I don't know, I'd have to think about that. But I've really persuaded myself over time that I think I should teach undergraduates about Python modules instead of Python classes. That is something I think. And I think the reason you can't do that is you can't have instances of a module, but I don't actually know how modules work. My impression is a lot of introductory computer science programs specifically teach the anti-pattern we were looking at called the God object, where, oh, we have to teach these undergrads objects right now, right away. We'll just put everything in an object. And not every problem demands the solution of an object. And not every problem demands the solution of a file. So some of you are in SQL right now, and the whole database is one file, right? Files don't exist in the database. That's weird. Like, that doesn't make sense to me. And that has also caused me to not know how to think about files. So I've been going around for years saying software engineering has been disproven, and no one's actually argued back with me, and I don't know if it's because it's like you don't argue with people that start like talking about the end times in public, or I don't know if it's because I'm so correct that everyone has instantly changed their mind when they've heard me speak. And I don't want to find out, which is why I've never said any of this in front of Professor Cordova, right? I don't want to know what'll happen to us, right? I do think, and I was part of software development teams, and I said, why are we doing Agile? They said, well, we make a lot of money by doing Agile. And I think that is a credible reason to keep doing Agile, right? But that isn't an argument that Agile is correct, right? And for me, I am interested in correctness academically, right? So you should all learn and know how to do Agile, because people are going to expect you to know how to do it. And in fact, you have noticed we've been on a 2-week cadence this entire term, right? I've simply avoided referring to them as sprints. But I've also been achieving encapsulation with that, right? And an astute student will note that we actually have a hierarchical file system governing our path through. But so I looked for some case studies, and so what I actually did is I looked up the thing that Microsoft was the most proud of using their closed source tech stack for this. And I believe this is in 2009, so I think this is before .NET went completely public. So I was like, what is the best .NET example? And so I found an advertising campaign called the Get the Facts campaign, which Microsoft, not yet then a $1 trillion company, highlighted one of the examples of their framework they were most proud of, which is the London Stock Exchange. They had claimed to have 5 nines reliability. We did 6 nines in aerospace, so that's 5 nines 1 in 100,000 or 10,000 failure rate. Yeah, 1 in 100,000. So you go out one day every 300 years. And anyways, shortly after that campaign, the London Stock Exchange switched to a Linux-based tech stack, which I think is hilarious. So I love it when Microsoft goes out and says, look how good we are at this thing, and then fails. Anyways, I have 4 citations for this. I don't know. I think one of these is from like Ars Technica. Oh, the Telegraph, right? And remember, this is all from way back when the United Kingdom was still part of Europe, right? So it was in a different continent then. So that's a long time ago. This is on the other side of continental drift. 10 years later, I hate to say my impression is Microsoft admitted defeat, but they released their own version of Linux at that time. And so now there are developers that work for Microsoft that maintain the Linux kernel, right? And interestingly enough, this is available CI/CD, also free to the public, available on GitHub, the same place all of the other Linux distributions are. Microsoft Windows still closed source to my knowledge, and also to my knowledge still contains C++ code, at least very, very close to the kernel, and also has correspondingly, in my view, low reliability. There was a big, probably still is, schism between Intel and Microsoft, right, the Wintel people, where Microsoft was extremely invested in Windows running on Intel's tech stack, but Intel does cyber-physical systems that have to have extremely high reliability and had to run Linux on the devices that they use to make the devices that run Windows, right? I'm just a hater. Build, test, deploy. Okay. CI, to me, I think of as being build and test, specifically the integration tests. Right, this is a technology for systems thinking, right? So there is corresponding physical technology, there is corresponding scripting technology, there is now infrastructure as code, there is now GitHub Actions. All of this is new. It worked just as well over tarballs and emails for decades. GitHub is way better now, but in fact, for GitHub to work, GitHub itself runs over CI/CD, so it is now self-compiling, right? Issues and pull requests are completely mature. Mailing lists are also completely mature. I like to play to the crowd. We've got a bunch of Rust fans around. So here is a current Linux kernel email list. This thing is still going, but in fact, you can just look up the Linux kernel on GitHub. And there it is. It's right there. It has pull requests. Unfortunately, because it's perfect, it has no issues, so this is a bad example, right? But if you happen to be running the Linux kernel on your PlayStation VR headset, you know, I don't know what's going on here.
You didn't see the one to start the rewrite in Java to be enterprise friendly.
Wait, what? What did you see?
1171.
Aren't Rust and the Linux kernel developers angry at each other right now for something?
Yeah, I think that's always true.
It's like a...
Who put all of this stuff on that garbage collection? Wow, this is so funny. More enterprise. Wait, someone answered?
that looks like an LLM generated block.
Oh, you think so?
I
Okay.
think it has to.
Yeah, okay. Well, this is going straight in the, That's the best thing I've ever read. Okay.
You haven't seen the GitHub roast, which is I think another an LLM-based thing where some people just open an issue on a random repository of yours with just a roast of your GitHub profile.
If you go on GitHub, please be nice to everyone, okay? They're all very stressed out, and most of them are underpaid because they're not working for Microsoft. If they're working for Microsoft, you can be mean to them. I have a very good friend who works for Microsoft and loves it when people are mean to her. So, right. Continuous deployment or delivery. I'm saying out of scope for this class, but you can think of the method I've used for sort of assignment management in this class is you're continuously deploying to my eyeballs at any given time. Via the Panopticon, I am monitoring all of your code. I actually have a 27 monitor setup at home, and it has all of your repositories open live. And I actually get notifications on my phone every time there's a push to any one of them. And I go check it, and I don't say a word, so you don't know that I'm looking, right? So I'm everywhere at all times. You can imagine that as continuous delivery from your current directory to Calvin Deutschbaum. Do you all know what the term DevOps means?
Developer operations.
Yeah, right. So I'll say how I understand it, which is site reliability engineering was like an unbelievably uncool way to explain something. And CI/CD has 4 letters in a row and 2 of them are C's, right? So there wasn't a great way to call this. So people just came up with DevOps, right? Stands for development operations. Historically, operations has been the IT people and development has been the software engineering people, right? Some, I guess we'll say very smart people, right? For some value, really smart, got together and said, don't the IT people do computer all day and the software engineer people do computer all day? Can't they just all do computer all day all together? And the answer was yes, infrastructure as code. And so that's just what's done now, right? It doesn't make sense that the IT people decide what operating system runs on the servers and then the software engineers decide what software to write. That's the same decision, right? The tech stack goes all the way down to the hardware. Well, for example, I'm going through, as you know, this laptop is about to explode. So I sent Wix, our IT people, an email. I was like, hey, can I get a new piece of hardware? And it turns out there's like a lot of rules. And that doesn't make sense to me. I think the development people and the IT people should be the same people. I think, to me, it is reasonable that I should be able to pick out what my own laptop is, right? And this is not the position of organizations which have a divide between development and operations, right? We have a firm divide here, and that divide is for a reason. And you could argue under systems thinking, that's encapsulation, right? That's good. We don't want those decisions crossing boundaries. It does seem like, in fact, there was never any reason for there to be a DevOps divide. I do wonder if this DevOps divide was never about things that made sense, but was about underpaying people. Many undergraduates from Willamette University, which is a small private liberal arts college, they take 10 courses in computer science for their major, and 5 of them are CS prefixed, and a lot of them go out and they do not get jobs that require a bachelor's of science in computer science, and they end up in IT and they get paid less. That kind of sucks for them, right? But the person that is paying them less and is still getting a CS major is probably doing pretty okay. And that was the person that made the decision to separate dev and ops, right? So that always, sort of the critical theory side of thinking about this suggests to me someone made a lot of money from software being a lot worse, right? And I don't know if that's true, but that's my impression. In this class, I have made some efforts to bridge this divide, and it is non-trivial to bridge this divide in a class like this, where I do not know what hardware we're working on, and I do not make the design decisions about what hardware we're on. Every year we have a few students with a Chromebook we have to try and teach to, and that is always challenging. And it's a form of challenge I enjoy, and not this student with the Chromebook very rarely enjoys that challenge, right? And that's just like not fair, because as a rule, if you come to an undergraduate school like this to major in computer science and have a Chromebook, it is like not because you come from a wealthy family, right? So that is like a real problem someone needs to solve, right? And so I'm always trying to push back against what I consider the arbitrary divide between the people that do computer, right? And so, for example, I've tried to integrate development and operations, and you saw just tonight how many times did I grab an operating system and a piece of software at the same time and run them together. And you saw when I attempted to run a GCC executable compiled on Alpine on Ubuntu, I couldn't even figure out what was going wrong. It doesn't make sense for there to be a divide between the development people and the operations people, because things are just weird and don't make sense, right? Separately, automation is excellent. I did not show a high degree of automation in all of the podman commands I was doing. We're going to solve that in a moment with make, but I solved it a little bit with the shell scripts. So you saw I had podman.sh, which automated launching the bind mounts, right? I really do view CI/CD, DevOps, site reliability engineering as, at most, different ways of referring to the same idea, like Blue and Azure, right? There is one other thing to think of, which is this sort of implementation client distinction, right? And I've often described this more so in the context of trying to advise people to do computer science or data science, right? And I always do it in the form of the pandas library. To me, I would expect a computer scientist to write pandas, to implement the data frames within pandas, to do the pi-arrow integration to get higher performance, to make the design decisions about how strings are stored in a data frame that lead to higher performance, and so on. This is very clear to me when I open a .rds file in Python, and it takes a long time to load, and I open a .pickle file in Python, and it loads instantly, even though the .pickle file is larger. These are all interesting to me. I find them academically interesting. It is not my impression that this seems interesting to the statisticians, right? The statisticians want to know about the relationships between the data within that data frame. And so they are clients of pandas. They use the features that are developed by the computer sciences in pandas. Ops is one level below that. As a computer scientist writing pandas, I am a client of operations. I use the hardware that has some operating system that's running on it. I do not necessarily implement the hardware. I do not procure the hardware. I do not make sure the power stays on. I do not plug in the Ethernet cables, right? I am a client, right? My impression from doing a little bit of data science is we should probably have the data scientists looking at how pandas is implemented, and we should probably have the computer scientists looking at how pandas is used. It doesn't make sense to have a firm divide there, and in fact, I'm a pandas developer and a pandas user, and I feel great about this, right? And I feel like it should be the same way about DevOps. In addition to me using the operating systems and using the physical hardware, I should have some involvement and understanding for how the hardware is developed and how the operating systems are defined and how they are imaged onto the devices. This doesn't seem useless. This seems more useful than knowing some other things I could learn. So, like, I have to spend a certain amount of cognitive energy, like remembering to carry my key fob around, right? If I'm going to do that already, that is completely unrelated to my job. I can spend a little bit of cognitive energy knowing my company's policy on operating systems, right? Because operating systems affect me every single command I run ever. And the key fob thing affects me 30 seconds a day. And if I get locked outside, Kale lets me in. There you are. Which was very convenient. So Podman to me is this software solution to the hardware problem. It's very interesting for that reason. There's 23 minutes left. Remember at the beginning of the term when I was like, we can probably get out of here at 9 every day. I have never once stopped talking before 10, right? And I think just like everything I say is just, oh, it's so good, right? Like, so I've really liked all the things I've said. I watch the videos when I get home. on 2X, you know. I feel like there's absolutely no way I'm going to do justice to this in 22 minutes. You said you basically know it already. Okay, cool. So GitHub and CI/CD. So GitHub Actions is, to my knowledge, the free way to do CI/CD. The competing forms are Jenkins and GitLab. GitLab definitely costs money. And apparently it's so easy to use you can't actually learn CI/CD doing it, which I don't know because it's not free, right? So I've never tried it. I tried to use GitHub Actions for a long time and it didn't work. So like I'm pretty sure you can learn how to do it using that. And it's much easier than it used to be. So these are integrated with GitHub repositories, which means in some way they're integrated with Git, even though Git and GitHub are not quite the same thing, right? And it has support for programming languages, including C. If you kind of like squint and don't look at it too close, they say there's this language called C/C++, and we just pretend that it says C89, right? Because we don't want those pluses anywhere near our C's, right? I referred to it as C++ the other day. Everyone liked that. Okay, so how does this work? There is a hidden GitHub workflows folder in repositories. Okay. Do I have, what did I type? I feel uncomfortable looking at this.
You don't want the live time?
I don't want live anything. Okay. Action. So, fun fact, lights, camera, and action are all 6 characters, so we can use all of them in this class. So I could give a talk called lights, camera, action. Okay, so let's open a few different things. Actually, do I already have it open here? Right. So I'm going to try and go back and forth between WebView and terminal view, right? So here is the action repository. I'll put this link in Discord. You can all follow this and do what you will. Is Discord open? Yeah, it is. Shout out grown-ups. Okay. The way I think of GitHub Actions as working is there is a hidden directory .github that contains a directory called workflows. What does this look like at the command line, which I think is more academically interesting to me? I am currently in the action repository. You can see that I am on the main branch. If I list the files, we don't see that much. If I list all of the files, I get these A's back. It's easier with L. We can say there's 5 files. That's not true. There's more than that because there's these hidden files. There's the current folder. There's the upper folder. There's .git. That just maintains the stuff that manages the repository for the git command. And then there's a .github hidden directory. I can access the .github hidden directory. It contains a directory called workflows. That directory called workflows corresponds to this directory. That contains something called c89.yaml. Do we all say YAML? Okay. Which stands for YAML's not a markup language and yet another markup language, a mutually recursive and self-contradictory initialism, which is, I hate it, right? Like, it's so terrible. Okay. Let's look at this YAML file, and I think it is going to have the nicest syntax formatting for our projectors on browser, so I'm going to look at it there. Workflows are composed of a trigger, jobs, and runners. And jobs are composed of steps. To me, it is easiest to think about jobs and steps. Steps are commands I would type in at the command line if I were running this manually, and jobs are combinations of commands I would type in at the command line that I would usually put inside one script. So I think of a job as a script, I think of a step as a command. Triggers are the circumstances under which these scripts are run, and runners are the devices on which these scripts are run, right? So what do we have over here? This is quite minimal. It probably could be slightly more minimal than it is, but I couldn't figure out if you need a name or not, and by couldn't figure out, I mean I was too lazy to check. I have no idea if names are required. I leave that as an exercise to the student, right? This is on push, so this is the trigger. This script, the job, runs every time there's a push event on this repository. Grammatically, what's going on here is something I would like to point out a little bit, which is that we have specifiers followed by attributes, I don't know, something like that, right? And they are always colon separated. Okay, I really don't like what it's doing with the click events. And so if you have the last specifier, that can go on the same line as the colon, but otherwise we nest them, and I think there's 2 spaces here. So this YAML language is, I don't know, it's a way of specifying things, right? And this is all over the place. So we have our trigger, which is on push. Do I go through all of that? I don't know. We have the jobs, and we only have one job here called build. Build, test, deploy, I'm only building, right? I'm not testing and deploying. I just trust my code. I just throw it out into the world, no matter how bad it is, right? I specify the runner. These runners are containers, but they're not containers. They seem to be something that's an awful lot like a container that lives in GitHub Container Registry that has very special namespaces going on. So that thing's called Ubuntu Latest, and I have pulled down the Ubuntu Latest container from Docker Hub many, many times, and it does not have GCC on it, which I find out every single time, and I'm always annoyed by. This Ubuntu Latest has GCC on it, which I know because this workflow works and I didn't install GCC.
There's a lot of stuff in the background. I'll send a YouTube video in the Discord that you'll enjoy.
This is like...
This is going to like destroy any positive sentiments you have about GitHub Actions, but...
I don't know that I have positive sentiments about it. It's interesting. I mean, GitHub Pages somehow deploys without generating an action.
It
has an action, but it doesn't have a workflow.
It didn't used to be action-based.
Yeah.
It used to just happen.
Oh, so they ported it over. That's what's going on. And I have a legacy version. Okay. I find that so annoying. I'm probably going to teach high schoolers CI/CD this summer in a summer camp in a week, so I should probably understand it. I don't think you need to understand it to explain it to high schoolers.
So question, like,
Yeah.
outside of sort of academic
Yeah.
lens, like, do people use GitHub Actions, like, in practice in the industry and stuff that you're aware of?
My impression is yes. So in my consulting work, one of the reasons I, as a computer scientist, got this over a software engineer is that one of the benefits I had was I did find this academically interesting, and it didn't challenge my ideas about how software should be written. But in fact, I was on a team with software engineers in industry, and they could find no corresponding academic that was in it. And we were developing curriculum to train people to do CI/CD DevOps, right? I believe at some point in the future, DevOps will be as dominant as Agile is now. And this is not the first time this has happened. When Agile came out, many people said, oh, this will never supplant waterfall, right? And it did. I don't know the timeline. This seems to be growing much faster than Agile did. And I think it has really, really strong benefits versus Agile, which is this costs way less money. My evidence to support how fast it's growing is the presence of this company called GitLab, which is one of the unicorns like tech companies that gets to $1 billion valuation. And it is one of the fastest companies to $1 billion valuation ever. And they're the only people, in my view, who solely monetize CI/CD. So I think this is blowing up very fast, and I think it will be dominant. I separately suspect companies that don't index into CI/CD are going to get run out of business by companies that do. They think the performance benefits to this will be markedly higher than the switch to Agile. So we'll see what happens, right? There is a reason GitHub built this.
Yeah. So is the CI/CD, is that like a recent, the past 5 to 10 years sort of breakthrough?
When did I start hearing of it? Well, I mean, really, Google's been doing it since 2004, but no one else could do it early on until everything moved onto the cloud. And when everything moved onto the cloud, which I think happened in 2020, that's when, because many companies were using on-premises when they probably should have been using cloud for a while in various factors. Do you know that?
Well, Jenkins and Circle,
Yeah.
Jenkins specifically has been around for a little bit.
10 years, do you think, or 5, or
Maybe longer than
Initial
10.
release 2011.
Yeah.
14 years? Okay. And Jenkins was the first one. Oh, it's Java-based. Oh, I forgot.
Circle is nice.
It runs in servers.
Okay, whatever. Yeah, this is the future. The same thing will happen to Agile as happened to Java. It's like we don't know how fast, we don't know when this will be the dominant paradigm. No one has shown any problems with it, and nothing's capable of challenging it at this time. I did have to think carefully about teaching you this versus something else, but I do look at jobs. So if you just look up software engineering jobs, in fact, many of them are not asking for DevOps, but there are enough openings in DevOps right now, and they are paying more. So I think it is okay for me to teach this. And I don't know that I felt that way 2 years ago. Yeah, I don't know. It's DevOps. It's trivial. Okay. Most commonly used in GitHub pages now, I think. So that's how I teach students it. I don't tell the students I'm teaching them CI/CD. They don't really need to know that. My website is extremely cursed, and I'm not proud of it. You can look at it if you want. But, well, let's look at an example. This is... So this is forked from someone else's repository. This is, wait, this should say from Jameson Watts somewhere on it. It doesn't. I'm not plagiarizing. There it is, from Jameson. So I just ripped someone else's repository, rendered all of the markdown to HTML, configured it to deploy to GitHub pages, and just like made a course website. And this was so close to fully automatic, right? Like this should not be allowed. It's unbelievable this worked, right? And it just did, right? And you can see how simple the commands are in here. They're not that complicated. Here's GHCR mentioned, right? I don't know, setup job. What do we have going on here? Render image. Are there any commands anywhere? And is this Docker mentioned? Docker mentioned? Docker and something that could get you a job? right? That's a web development Docker image, right? All these things are interesting. I think there's a bunch of, what? SHA 256 in real life? That's what I got. I got it. That's me. That's us now. It was me, now it's us, right? So basically this class is awesome. What's this? That YAML? This is yet another markdown language, right? Oh, what's this one? Oh, it's relative paths. That's an absolute path because that's root. But right, that we have get's being used. Get's using get to get. Okay. So, anyways, I feel great about what I'm teaching you this term. I'm super cool. Okay. Whew, got that out of the way. Okay. Docker mentioned. GitHub Pages is not quite hard enough to use, which annoys me a little bit, so I'm going to find some way to make it harder before I teach it. But I taught it in an undergraduate writing class with no technical requirements, right? I was like, hey, students, you probably want to be bloggers. You know what bloggers love? Markdown. And they, sort of believe me, right? I'm pitching a class next year. I was like, you should let me teach a no prerequisite scientific computing class where I teach students how to use LaTeX and some typesetting tools and the Linux command line, and then just send them back into the English department to write all of their stuff in that format and see what happens, right? Because I've had some really good English majors in the CS classes, and they only take one class, and I was like, I don't think we should teach you object-oriented, I think we should teach you about the Linux command line, right? So, anyways, CI. I found GitHub Actions pretty underdocumented. I'm wondering if that's what the video's going to show if you post something, but
It's nothing to do with the documentation, it's more about the technical aspects of it.
Well, I suspect that's related because my questions were how's this work? And the documentation's here's a template. And I'm like, I didn't really want a template. I sort of wanted to write my own template. And they're like, you have to use version 4 of this. And I was like, there's no version 3? Right? There's stink all over. There's code smell. We were talking about code smell earlier. This stuff is awful. But someone's going to fix it someday because it's really cool, right? And maybe GitLab fixed it, and that's why GitLab works. Maybe this stuff doesn't have to be hard. It just feels like it has to be hard because everyone's been doing it wrong.
It's ported directly from Azure.
Oh, Azure mentioned. I love Microsoft. Okay. Here's the starter workflow. I want you to see how much worse this looks than the one I gave you. What? Why? Why do you have pull requests on default branch? Who specified this? Is this for developers? Do I look like a software developer? Right? So, anyways, this isn't that bad. They just have more makes. And you don't know what make is yet. And that's okay. So, this is awful. This is what I made. Look at this. 23, 21 lines. I took out 12 lines. I removed more than 50% of the lines and lost no functionality. Now, it is true I did that by writing the most cursed make file you've ever seen in your life, but you haven't seen that yet, so you don't know how bad it is, right? Specify the name, we specify on push events, we specify the jobs. I just broke this down for you. You can review it. GitHub runners were interesting. 7 minutes. Jeez. Okay. We're just going to, click next a bunch. YAML mentioned, for those of you that look at the source code for my websites, I am currently specifying the styling in YAML as well, so this is another place YAML shows up. Do you all use YAML headers at the top of your R Markdown documents in Data 505, 502? Those are the ones you do RN, right? So this is, that's a Quarto header, but I think it's the same in an R Markdown header, right? A lot of people don't know this, but the internet is named after the hit cinema release Madam Web. So when I say Je suis développeur web, that's referring to Madam Web, right, from the Marvel Cinematic Universe. Okay. Anyways, that's enough on GitHub Actions. You all know about them. I'm going to talk about make as fast as I can for 6 minutes. Okay. So, what? 5 minutes? My bad. It says 6 minutes over here. Just get up and leave. Okay. So make, it came out in 1976, good year. Carter won? Jimmy Carter, highest favorability of any U.S. president in my lifetime. And I think it was designed by people that got really annoyed that they had to keep specifying the C89 standard, which hadn't come out for another 13 years, right? So that was very annoying to them, right? CMake is too new. We don't trust it. It's only 25 years old, not stable yet. So you're not allowed to learn about CMake in this class. So make stores big commands. I've showed you the example. I'm out of water too. I've showed the example of some big commands, and make is essentially programmed with a make file. Here's an example of a minimal make file. Make files are structured around rules, and wow, does that look an awful lot like YAML. I wonder what the YAML people got their idea from. Unless, in 1976, those people saw forward into the future and saw how popular YAML was and invented make to be future compatible, which is what I think happened. So what is this? This is a rule, which is sort of a variable. It is colon terminated, then there's a tab character. That is four spaces. That will not work. If you copy paste this into a make file, it will break. I found that out today. When I rendered this from my device into part of Markdown into HTML, this thing broke. My bad. You have to put a tab there, and then you say GCC shank, and that will work. And you have access to the actions repository. So I can put a minimal C file inside shank. This C file will draw errors because printf is undefined. I have an implicit declaration of printf. And we can see that if I GCC shank it, I get the warning. It's not an error, it's a warning. And if I run make runs the same command gcc shank.c. I get the same warnings, I get the same behavior. This is a way of saving commands. Okay. Make runs shell commands. With a few caveats, it does not run bash, it runs .sh, which means it broke one of my autograders unexpectedly, which I have to fix for next year. You, of course, can run a bash script from inside sh, which feels awful. I was like, ugh. And these things are called rules. By default, the first rule runs, and you can specify dependencies for rules, which means later rules can run first. So you can build dependency trees inside your make file. Here is one way to use this. I have make build, so by default I run shank, and then when I specify no warn, I get the warning tag removed. And when I run that, no warning, it just, so make build gets the error, or we can use no warn and we get things directly. You can either specify the rule or you get the first one by default. There's an entire tutorial on make file. Okay, I think you could probably spend 10 years just learning make files, and you would enjoy every single one of those 10 years. Everything I've learned about make files, I'm like, oh, that's so cool. Like, they have like multiple kinds of variables, right? So here's an example of a make file that I use. I remove the executable with make clean, and by default I build. It's very nice to use make clean to clean up directories. 2 minutes. I have a monster test script under make check. So if I run all of this, I generated a bunch of text files that were being used in my testing script. That's bad and gross. So what I can do is I can make clean, and then I can get rid of those things, right? So that can be nice. This is the SHA testing script. Yeah, we're done, right? This doesn't work because it's bash and not sh. You can't use subprocesses. You have to pipe everything through named files. And I shouldn't even say pipe. You have to direct everything through named files. I'm not sure if you can use pipes or not. I didn't try. Curl breaks all the time. I need to switch to wget. I like curl so much because it's so much simpler. But wget works 100% of the time. And I can prove this. You're still here. Why are you still here? That's weird. Okay. That should work. And I can prove it because if I wget the same URL, do people say wget? They don't say wget, do they?
I've never heard that.
So that's Pride and Prejudice. Or I don't know that we can tell it's Pride and Prejudice. Well, let's see. Good night. Yes, it is Pride and Prejudice. Okay. Jane Austen W. Right. You can get the make files to return 0 or non-zero values. 0 values are not detected as errors by GitHub Actions. 1 values are. So all you have to do is write your code to return 1s when there's problems, and then the GitHub Actions will return problems. Mine automatically generates emails. You can configure it. Go check it out. I've given you an example GitHub Actions thing. My recommendation is if you are into this, place your entire crypto thing under CI/CD. And if you're not, don't. See you in 2 weeks.
Actions will run from
Wait, what'd you say?
you can have like scheduled actions like with like cron syntax.
Yes. Yeah.
Which underlies a project that I wrote in my previous job, which now has the best shell script I've ever written.